Hello everyone, welcome to Scalers YouTube channel. My name is Aditya. I'm currently working as a data architect at PepsiCo. In the first module, we are going to discuss about the basics of data engineering, difference between big data and data engineering, how big data came into the market, and the 5 E's of big data. We'll also discuss about the pay scale of an average big data engineer and how one can get started with the initial basics of big data. Before deep diving into the session, do not forget to check out the Scalar masterclasses taken by the leading industry expert at Scalar event page. The link is in the description below. If you want to watch similar content in future, please do subscribe to Scalar YouTube channel. And now let's get started.
So, what is data engineering? Data engineering is a concept or a kind of branch related to data where the engineers build systems which are used to collect, store, and process data. So basically, engineers as a team work together to fetch data from different source systems. When I talk about fetching the data, it's basically collecting the data in the proper format, storing the data in the required volume, and then processing the data as per the business requirement or the use case scenario. But why data engineering is so much of important these days? As you see all the devices around you, be it your watch, be it your Wi-Fi, your TV, anything which is running on the internet is somehow storing some data, consuming some data, or using some data in some of the forms for a business analytical purpose. So companies these days utilize a lot of data which is coming out of these devices. They are using customer based data to, understand the customer centric behavior and then use those data to drive their own business. So data related jobs are becoming that famous in the market. Like people are hiring engineers for data analysis, basically analyzing the data, for building the data platforms, which data engineering people will be doing. Then there are data scientists who will be, building models on top of the fetched data, which data engineering people are getting. These models will be helpful to do some kind of predictions or some kind of recommendations for any business purpose. So that's why to carry out any downstream processing of the data should be fetched from different source system in a particular format, in a particular quality, so that it can be directly consumed. These all kind of work is done by a data engineer, right? So I can write here data engineering. It is a concept or a branch of engineering. I wouldn't say a concept, a branch, but I will say it's a concept of engineering where engineers build scalable, secured systems. I would also add resilient, basically a kind of a fault tolerant systems to collect the data, store the data. Number three, process the data. So data engineering is a concept of engineering where engineers build scalable. What is scalable? Anything which can be scaled up, which can be increased or enhanced. So engineers build scalable system, secured system, and resilient systems. Resilient is like kind of anything if it something fails, it tends to bring or go back to its original state, right? So engineers try to build a system which can be scaled, which is secured from any kind of harmful activities from outside, and is resilient to go back to its initial stage in case of any failure, right? So this system is basically meant to collect the data, to store the data, and to process the data. Let me, yeah. So this data, when fetched, is then sent to downstream for further analytical purpose, such as reporting or data science modeling, right? So we'll also talk about the roles or responsibility of a data engineer. So I'll write data engineer short form as DE. make sure whenever I write DE, it means data engineer. So number one is to build scalable system. I have already written scalable word to build a fault tolerant system, to build a private slash secured system, to fetch the data in right format, to fetch the data in, I would say, accurate state. Basically, we're talking about quality or consistency of data over here. Consistency. Then the data is private. Basically, private data means we are not leaking out some confidential information which is used by the companies, right? Number seven, to ensure proper data governance is in place when the data is being fetched and consumed, right? These are the basic responsibilities of a data engineer, right? And to come to the question, so we talk about what is data engineering. I'll now talk about why data engineering. So the short answer will be because of invention, because of invention of internet, most of the devices, I will say most of the devices are running, which produces some or other kind of data. I can say example, your digital watch, right? Your mobile phone. You can take your sound system, right? Your Wi-Fi, which stores your password and your user ID. So all these devices is running on some or the other kind of data. So companies understood that data is new oil, right? For company, data is new oil, which means they want to leverage the data so that they can understand the customer behavior in advance so that they can plan their resources. When I talk about resources, it is both the expenses in terms of manpower or cost. They can plan their expenses or cost accordingly. They can understand how the business is performing in upcoming months, where they need to bring additional workforce, or where they need to invest, basically, or where they need to cut the resources. Basically, where the growth is not happening or where the company is not doing right in terms of business, they want to cut the resources, right? Because for the company the data is new oil, they want to fetch all of this data, and it becomes very important for them to hire right kind of resources, basically data engineers, who can perform this, fetching the data, processing the data, and providing the right kind of data for the end users or for the downstream people so that they can perform the analysis properly, right? And that's the reason, based on this point, because the data is new oil, and because most of the companies have understood, right, like to understand the customer behavior, to understand the trends of how the customer purchases an item in the market, most of the jobs are now turning towards data. Apart from that, there was a major shift which is things becoming digital. Basically, no need of persons or involvement. During the COVID period, we have seen like people are not going outside. They are buying everything from their home, using their phones by using some application. Everything which previously required my presence, my personal presence, now can be done, virtually. All your office meetings you are attending virtually. You can buy any item sitting at your home. You can order food. You can deliver something to some of your friends. Uh, you name something, everything can be done virtually these days, right? Your banking system, your paying your bills, booking a train ticket, booking a flight ticket, everything is now, done through internet. And everywhere, wherever internet is used, data is being formed or data is being consumed by these devices or these applications. So company wants these kind of data to, they want to tap this kind of data so that they can understand where exactly more customers are going, and they can study the trends of the market, and then accordingly they want, you know, to invest in the business. To do all this kind of work, a right mindset or a right resource is required who has to be trained on data. So that's why there's a sudden surge of data related jobs, basically data analyst, data scientist, and data engineers, where people are, started leveraging the tools and technologies to upskill so that they are the right kind of resources for the company, right? So we've discussed what is data engineering, why data engineering, and why the data related jobs are so much of hype in the market. Let me now discuss the difference between a data engineer, a data analyst, and data scientist. We'll discuss this point with a very basic understanding or basic layman example. So I've already discussed a data engineer. Data engineer role is to fetch the data in right format and process it as per the requirement, right? So data engineer, I'll give you an example, right? What is data engineer, what is data analyst, and what is data scientist? Data analyst is a person who analyzes the data by building some kind of reports or dashboards, right? They compare the data source, which is source of truth, with the end or the final consumable data. So basically, they compare the initial data source, the first source of truth, with the end or the final consumable data. Data analysts builds reports or dashboards by using different tools like Tableau, Power BI, and they perform some kind of analysis by using Excel, by using different tools to make sure the data is consistent across different environment. There is no uh, issue in terms of data quality, right? That's the role of a data analyst. They analyze the data to make sure it is consistent across different environment. Now, what is data scientist? I'll give you a random or layman example also, which you can explain in the interview, which can help you to impress an interviewer. Data scientist is a person who performs advanced analytics on the final data to build models for recommendation or for predictions. I'll give you a normal example. Let's say in Amazon, if you go and purchase something today, based on your last purchase, Amazon will give you a different kind of recommendations which he or she can purchase along with that particular item. This doesn't happen for the first time, but slowly, by understanding your purchase trends, Amazon is going to throw some kind of recommendations, basically telling you to buy those products along with these products, right? By doing so, we are going to tell customer like, okay, you have bought so and so product XYZ in the past. It's better if you buy this product along with this product at some discounted price. So these are kind of promotions to the customer to help them buy better, right? Also buy something at a discounted price. At the same time, the company is able to meet their, targets. So data scientist is using the trends or the data of how a customer purchases or performs a purchase in any application. I'm just giving you an example. Based on that data, the data scientists build a kind of model for recommendation of a predictions. For predictions such as, I can give you an example. Let's say New Delhi, in Sector 8, road number 8, there is a lot of traffic. Uh, they want to divert that traffic. So based on some predictory models, they can understand, okay, which lane or which road to be taken so that the traffic or the congestion is not that high, right? To understand all the three examples or all the three roles at a time, I can give you a random example. Let's say your mom has given you a list of items to buy from different grocery stores, right? These items cannot be found in a single supermarket. Let's assume like you have to go to different shops or different vendors across your home to fetch all these kind of items. Let's say there are some 20-30 items on a list which your mom has told you to buy. So you go to shop one, you find like out of 20, only one or two items are present. You go to shop two, again you find some items, let's say three items. You go to four or five shops and you then complete all the 20 items which are present in the list. So when you're going to different shops, you fetch the item, you compare the price of the item, you see the quality of the item, you see if that is exactly the item which your mother has asked you to fetch, right? Basically, you're checking the format of that item, you're checking the quality, you're checking the expiry date of that item, whether it is correct or not. All these things, what you're doing is kind of a work of a data engineer. You're putting all the items in a basket and you are moving that items to a kitchen. Basically, you are building a pipeline or a system which moves all these items from the shops to the kitchen, right? And you have washed all these items. You have, let's say, you have purchased some fruits or vegetables. You are washing the items. Basically, you are transforming these items. So all these kind of things are done by a data engineer, right? Now, let's say your sister, she is a data analyst. She will check whether your mom has asked you to buy, let's say, hybrid tomato, but you have purchased local tomato, right? So she will analyze, okay, whether the items on the list is exactly the same items which has been, told by a mom to, purchase. So this is the kind of work which a data analyst will do. She will make sure like what all items have been purchased are according to the list, right? Basically ensuring the quality of the data, checking if it is correct or not, checking the availability of the data, right? Then data scientist. Your mom is a data scientist. She will build the models. Basically, she is the end consumption. I can say she's the end consumption of what all items you have bought. It's up upon her what she wants to build, and she will build. Let's say she will build some kind of models as a data scientist. Just giving a random example. So this way you can connect all these three job roles with a normal example. I hope you have liked it. You can explain it in an interview, and basically it is going to impress the interviewer. Now let's talk about the third thing, which is a difference between a big data developer and a data engineer. So if you talk about a big data developer, these jobs were present early in the 90s till 2002, 2005. Uh, this was a time when internet came into picture, a lot of data was being consumed, a lot of data was being produced. Uh, Big data developer basically used to develop all the systems, all those technology to process the big data, obviously. And post 2005, the terminology got changed to data engineering. So if anyone asks you the difference between big data developer and data engineering, data engineer, basically both are the same things. It's like interchangeable words. So just the thing is like there are some kind of skill set here and there which is changing, but the work wise, work is same. So if I talk about big data developer, uh, since this kind of job roles existed across 90s to 2005 or 6, we can say big data developer usually worked on-premise. I'll explain on-premise in, I think, model 2. So big data developer, they usually work on on-premise, Hadoop, SQL, Hive, MapReduce, etc., etc. But again, the job got evolved with a lot of more new technologies, such as Apache Spark. Uh, they worked on Scoop, etc., etc. But yeah, there were more of skills, that day, uh, which helped a person to become a big data developer. But coming to 2006 till date, data engineering word was coined, and the skills which are required are cloud technology. Basically, I'm telling you the skills which I used to differentiate between the two jobs, right? There's no Hadoop, but there is a kind of Spark. Basics of Hadoop is still required. There is Python, there is Scala, and most of the work is coming across cloud technology. So any batch streaming tool, etc., etc. So if someone asks you what is the main difference between a big data developer and a big data engineer, both are same. Just that one is an old kind of job, and that job got evolved into a newer job, which is data engineering, right? So do not get confused. Both are same, like same brothers, but yeah, name being different, right? Now let's talk about point number 4, which is what is big data, how big data came into picture. So for this also, I'm going to give you a layman example to explain what is big data, how it evolved, how it came into the picture, basically why companies thought of a need to classify your data as big data. And then we'll talk about the different 4 V's or 5 V's to classify any kind of data as a big data. So what is big data? As I told, after the invention of internet, many of the devices started running on internet, because of which a lot of data was produced. A lot of data was consumed also by different devices. Most of the devices now are digital. They consume a lot of data. Obviously, when I talk about data, it means internet. And they produce data also, obviously, which is being stored somewhere in the cloud. So when there's so much of data being produced, leave about the processing part. That is the secondary part which companies were worried about. The primary issue, the company was thinking how they can store this huge amount of data. If you remember, when we were small, there used to be cassettes, video cassette or cassettes, which we used to use to play music or to watch a movie. Then came CDs, then came DVDs, then pen drive, hard disk, external hard disk. Now we are using cloud. So company understood, okay, the major issue is storing the data, because data is coming from different devices at different rate, frequency. So processing is the second part. First part is how we store it. So that's where they realized, okay, they need to have a kind of a framework or a technology which can store this high evolving data. So that's where when big data came into picture. So in 1980s or 1990s, I'm not pretty sure of the date, but yeah, this big data came into the market. People started realizing, okay, there are some data which is of very high size, huge volume capacity. It can come at any different rates, and we need to store this kind of data, so that if we process it, we are going to get some kind of return. But processing was not the major issue. They wanted to store this data so that they can retrieve it. Let me give you an example. If you go to a library, previously we used to maintain all those big registers, right? Who is purchasing which book, or who is taking which book when they're going to return. So whenever you used to visit a library, they used to see those big registers. Now think of an current time where all this data is sitting somewhere in a database. I need not maintain all this register, right? But this is a very huge ton of data. So instead of me maintaining all those manual registers, I can store it somewhere in a software, in a database. I can retrieve them as per the need, right? So company realize, okay, let us have a kind of technology where we can store this huge amount of data, which can be processed further depending upon the need. So that's when big data came in the market. So any data, let me write about big data. What is big data? Any data which cannot be stored on conventional system is called as big data. When I say conventional system, it means conventional systems means uh, CDs, DVDs, drives, etc. Any data which cannot be stored on conventional system is called as a big data. Big data came into the picture because of high usage of internet. A lot of data got produced, so company realized, okay, we need to store this data. Now let's talk about what are the four V's or five V's to classify any data as a big data. So four V's, or it got recently changed to five V's of big data. We are going to discuss each one of them one by one. Number one, volume. Number two, velocity, variety, veracity, value. So volume. If the size of data is so high that it cannot be stored in a single system, or it cannot be stored in a conventional system in a conventional manner, so that kind of data can be classified as a big data. So when I'm talking about volume, these volume means petabytes of data, or it's like trillions of data. So when volume of data is so high that it cannot be stored in a single system, that means I need to term that kind of data as a big data, right? When volume of data being produced is very high, that it becomes difficult for us to store it in conventional system, then we need to classify that data as a big data. Okay. Now let's talk about velocity. So if the volume of the data is very high, then obviously I cannot store it in the conventional devices or systems. I need to have a new system, a new technology to process and store this kind of huge volume data, right? That's why I'm terming that kind of data is a big data. Now let's talk about velocity. The rate or the speed at which this data is coming. If the rate is very high or the speed is very high, then also I need to classify this data as a big data. For example, if I go to any supermarket and if I swipe my credit card, you see within seconds of a time, after I swipe my credit card, I get a message in my system, in my phone basically, that some amount has been deducted. Same message on the phone goes via email on my email ID as well. So whenever a transaction is happening, there is a messaging queue being triggered, alerting me that some transaction happened. Basically, an amount got deducted from my account. The same amount went to merchant, and the merchant will be notified as well, right? So all these messagings, all this velocity of data transfer happens so fast that we need a big data processing system for the same kind of data. That's why any system which produces or consumes data at high frequency to process or store such high frequent data, we need to have big data system or framework, right? Now let's talk about variety. Data can be of different variety. It can be structured, semi-structured, unstructured. A data which can be stored in the form of tables is called as a structured data. A data which is not exactly structured, uh, where a schema cannot be attached to it, it can be called as a semi-structured data, example, your JSON, your XML, data which are like completely unstructured, which I cannot store in a structured format. For example, my audio clip, my audio voice message, or any video message basically are unstructured data. So data is present in a different format across different areas. So I need to bring all this data on a single common platform and make sure the data is in a consistent format. So whenever the data variety is different, so I can write like if the variety or structure of data is changing, that means that data has to be classified as big data. So if the data is present in different varieties or in a different format or different structure, we need to classify that data as a big data. So what is veracity? So veracity is mainly talking about the consistency or quality of data, right? If the consistency or the quality of data is changing from layer to layer or from environment to environment, basically one data in one environment looks different. So to process those kind of data also, I need to have a big data system or a big data environment. So that kind of data again is called as big data. So basically, if the data quality or consistency is changing based on layers or environment, then the data can be classified as big data, right? The final point, value, it was coined very recently. I'm not sure when, but yeah, value is to make sure whatever data we are fetching, the end data, that should be of very high value. It shouldn't be a case like we have fetched a lot of data from different system, we have transformed it, and then we realize that the fetched data cannot be leveraged or cannot be realized to get a beneficial output, right? So we need to make sure if the data which you're fetching is of very high value, then we need to classify that data as a big data, right? If the data being fetched is of high value, then also we can classify that data as big data, right? So we have understood what is big data, uh, how it came into reality, and what are the five V's to classify a data as a big data, right? Now let's go to point number five, which is skill sets required to become a data engineer in 2024 and how can I move from these roles to data engineering. Let me talk about it. I might be using Paint for it somewhere, but yeah, we'll discuss about it. This is question number four. Let me skills. So there are n number of skills required to become data engineering. Mastering few of them will help you down the line. So we'll start with basic SQL, database, basically RDBMS, right? We'll talk about ETL concept, extract, transform, and load, or ELT concept, extract, load, transform. We are going to discuss the difference between these two in model 2 basically. Uh, then we are going to talk about cloud concepts, right? Basics of big data such as distributed processing, parallel processing, distributed system, etc., etc. Then sometimes you need a data modeling concept or a data warehousing concept. Then you need data structures slash algorithms. So a person should understand which format or which structure of data should be used to store the data. It can be a list, it can be a dictionary. So depending upon the use case, the person should have the knowledge how the data has to be stored. So that is one more thing. Then for stream processing, we have tools like for stream processing. I can write tools like Kafka. We have skills like Azure, Data Factory. It's an ETL tool. Again, it depends upon the cloud. So I need not write it here, but yeah, cloud tools I can write. Above was cloud concept, and this is cloud tools and technologies, right? You need Spark, Apache Spark, very, very important. So I think these are the, you know, major skill set which every data engineer should be knowing. Again, depends upon the depth you want to go, but yeah, most of the time these are the skill sets which are required or which are basically asked in the interviews, be it a normal company to a Fortune 500 company, right? Now we're going to talk about how a person from any domain or from any skill can, you know, move from a data analyst role, a business analyst role, or a DBA role to a data engineer. I'm going to explain you thoughtfully how one can move from these roles, right? Let me take a paint. Let me take a new file. Don't save. I'm going to draw a Venn diagram basically, uh, which will help you to visualize or understand. Let me take another circle, put it over here, right? This is DE, which is data engineering. This is data analyst or business analyst, let's say one of the same. Data scientist, data scientist. Okay. We can take one more circle, a smaller circle, which is a DBA. DBA is more towards uh, data analyst or business analyst kind of work. But yeah, you can visualize like this small circle. I can write here a DBA, database administrator, right? For data engineering, let me expand this and let me increase the font size so that it is visible. Data engineering. I hope my size is good. If not, I'll increase further. Data engineering, I have told you the skills. I'll just copy and paste the same thing. Okay, right? Data analyst uh, is basically SQL, Python, cloud these days, little bit, yes, cloud concept, Excel, advanced Excel. Excel sometimes is also used in data engineering. Excel is something which is used across all the job roles, so I need not mention them, right? Power BI or Tableau, right? I can write here a data engineering is DE equal to DA, basically data analyst, plus additional skills, right? So if a person wants to move from data analyst to data engineering, these skills he or she should know. On top of that, the additional skills, whatever you have mentioned here, if they can learn, they can move from a data analyst to a data engineer, right? Then who is a DBA? A database administrator should know SQL, should know RDBMS. Sometimes they know scripting language such as Unix or Linux, right? They know cloud concepts these days. right? So these are the major skills of a database administrator. They majorly work on on-premise, but yeah, depending upon the company to company, they might change from on-premise to cloud. Uh, DE is also equal to DVA plus additional skills. A DBA can also become a data engineer provided he or she learns all those skills which are required, as I have mentioned above. So, data engineering already knows these things, but on top of that, what are additional things they need to learn so that they can, you know, start appearing for data engineering roles or the interviews. Now comes data scientist. So, few of the skills for data scientists are different. I write them. So, SQL is important again. Python is again important. They also need mathematical skills such as statistics. What happened? Statistics, probability, linear algebra, calculus, etc. etc. Then they need to know reporting sometimes, sometimes not majorly. They should know R, right? That's the major thing, and cloud concepts obviously, because they are also working on cloud concepts or ETL, ELT. They should also know, right? So if a person from data engineering background, obviously they have more skills. If they can learn this mathematical skills, on top of that, they need to know prediction analysis, modeling, or building models, basically building AI ML models. So artificial intelligence is another concept for data scientists. Machine learning is another concept for data scientists. If a data engineer wants to move to data scientist, uh, apart from SQL, Python, and cloud concept, they have to learn the rest of the other skills. I hope I have given a holistic difference of the skill set based upon different roles, based upon different expertise. I hope this chart or this Venn diagram is going to help you. Majorly, if you see this color, which I can highlight this is the part which is SQL, Python, some kind of reporting tools, which all the job roles are required, to upskill with. So you can start targeting those skills, and then slowly you can learning more skills in technology as per the job role. Let's go back to our discussion, which is module one of data engineering. Okay, we have discussed skills which are required to become a data engineer, and then how can one move from these roles to data engineering. Now let's go to question number 6, and this concept will help you cement your fundamentals on big data or data engineering. Let me write it over here and let's move to the top of the page. Again, I'll be using Paint to explain you in a diagrammatical fashion the difference between monolithic system and distributed system. So monolithic system is like traditional system. These are called as vertical system. You can scale up vertically by adding more resources on top of the system. You can increase the storage by getting more RAM, more CPU. That's where monolithic system came into picture. But distributed is something different. So let me not waste much time. Let me open my paint and show you practically. Let me take a new window and save it. I'll take this as a monolithic system and this one as a distributed system. So in an interview, you can always, remember the drawing and you can explain them easily, right? So let's say this is my initial system. So let me take this as A, B, C, D. So initially my system has some kind of RAM. RAM is basically random access memory. It's a kind of a storage. My initial system A had a lot of data, and beyond which now it cannot be scaled up. And because of the performance issue, I have decided, okay, I need to scale the system. So I bring some additional resource on top of A. Now this becomes, I can write here as, here I write something like A plus B, right? So these two systems together becomes one system. We have brought in additional system to get more storage, to get more compute. Now let's say after a certain time, again, my threshold limit has been reached where I can't scale up. So I bring another system, on top of A plus B. So now it becomes A plus B plus C. A plus B plus C. Basically, I have bought in additional resource to increase the storage, to increase the compute, right? And as the data grows, again, obviously A plus B plus C will reach its threshold. And then again, I decide, okay, I can bring some additional resource or storage to accommodate the increased capacity. Then now it becomes A plus B plus C plus D. But this adding additional resources can go up to a limit only. Because after a certain stage, you see, okay, you keep you keep on adding resources or storage, but after a certain time, there's not much performance benefit or performance gain, right? So this system mainly, I can classify it as a monolithic system, a major traditional system, monolithic system. Expand this. This is distributed system. I'll give you a good example which you can remember during your interview. So distributed system. Okay. Uh, I can call this entire architecture as a distributed architecture or a worker slave architecture, right? So parent child architecture also you can call worker slave architecture. It's upon you, whatever you want to call, you can call distributed architecture basically, right? So let's say I had some kind of work to be performed. Let's say X is a work to be performed. I'm distributing the work X between the different workers A, B, C, D, and E. So all these worker nodes A, B, C, D, and E are working parallelly. So a part of work is submitted to A part of work is submitted to B, and so on and so forth up to E. All these workers are live, working together parallelly, splitting the work between themselves. The output of all these worker nodes is again combined to get X. This kind of architecture we call it as a distributed architecture, right? So obviously in this system, not everything is being worked parallelly because all the work is done simultaneously by a single system. But here, the same work is divided between the number of resources. It's just like a project. In a project, one project is divided between the resources based upon their bandwidth. So to produce X work, I'm dividing that X work between 1, 2, 3, 4, 5 workers. And all these workers are working parallelly. The output of all the workers will be combined together to get the final result, which is X. So this kind of architecture is called distributed architecture or parallel processing architecture, right? MPP is again one of the concept, massive parallel processing, which we'll be discussing in module 2 of data engineering, right? This kind of architecture is called a distributed architecture. So best example I can give you is Indian wedding. Let's say you need to cook food for around 500 guests, right? So you ask some kind of caterers, you order a caterer to cook that food for the guest. So there will be a master chef uh, who will have, let's say, 10 to 15 workers below him. Some workers, let's say, two, three workers are cutting vegetables, two, three workers are preparing some sauce or some item which has to be, garnished with the vegetables. Some workers are cleaning utensils. Some workers are putting the fire or the stove or making the stove ready. Some workers are only to stir the vegetables once it is, you know, put in the pan. So all the workers are working together for the end result. And finally, the master chef. Basically, this master chef or this master node. These are worker nodes. This is called master node. The master node checks how the other nodes is working, or he checks or manages the task, whether the worker node is performing his or her task properly or not, or whether the worker node is alive or not, basically performing his day-to-day operation, right? So this kind of architecture, which I have given you the example of a master chef and the workers below him, can be called as a distributed architecture, right? Master chef will basically go and taste the final output just to understand, okay, whether the cooked food is very good, if it can be served or not. So this is the major task, to manage, to check how the workers are working, if they're working properly or not. It's a kind of a work done by a master node. Let's go back to the slide which we have prepared. So we have talked about the difference between monolithic system and a distributed system. Let's go to question number 7, pay scale of modern data engineers. So there's no standard answer for this question, but yeah, 2023 result, I can say 2024 has just started. So on average, we'll talk about average figures on average and based upon the average experience on average for 3 years experience guy in a Fortune 500 company, the pay is 17 LPA. This is the average pay of a 3 years Fortune 500 company resource. But again, if it's a service company, 3 years, it is around 11 LPA. Basically, these are for service companies. I'm talking about a 3 years experience. So more the experience, more the pay. It again differs from company to company, the brand or the rank or which designation you're going. So data engineers, there's a proper designation also. There are designations like associate data engineer, data engineer, senior data engineer, uh, principal data engineer, data architect, etc. etc. So associate data engineer up to 2 years, 2 years, data engineer 2 years to 3 years, senior anything 4 plus to 7 I can say, 7 years. Some companies like Facebook, Amazon, Google, it again changes. Senior data engineers like SD2, SD3. Principal data engineer, 11 plus to 15, right? Data architect again, 8 to 15, depends again company. Roles keep on changing, but I have given you just an average figure for a 3 years experience guy. Again, with the experience of with based upon your past salary, based upon your previous brand of the company, the salaries can vary. So there's not a fixed salary, but yeah, the trends for the freshers or for the 3 years experience resources in the market, the trends are good, the packages are good, right? Let us go to the last point, which is point number 8, emerging trends in the market post Gen AI for data engineers. So I keep hearing from people asking me these questions that, hey Aditya, will there be job cuts for data engineers in the market? So there won't be any job cut. Uh, Generative AI will basically make our lives much more easy So a data engineer can easily use tools such as GenAI to improve their current existing systems, to change the code or logic or build some kind of enhancement on the current system. So it's a kind of a calculator which you can utilize to enhance your current calculations, right? So for data engineers, GenAI can be integrated with some systems which are previously built to make sure the solutions whatever you're using are using some generative AI models output to understand whether the current systems are performing well or not. You can take some kind of help from Gen AI models to see if the fetch data can be made much more better. If you can enhance the system which can fetch data easily or at a high speed or a high velocity. You can also check if the data which is being fetched is applying all the data governance rule, making sure Gen AI has enabled, best practices for the engineers to follow. So all these trends which are emerging because of Gen AI in the market can be integrated with data engineering, which can help a data engineer to perform his or her work properly. It is not uh, going to cut jobs, but yeah, the mundane task which a data engineer does, that can be removed, that can be made little bit, reduced. But yeah, most of the times we need to figure out, okay, how we can enhance or how we can enable some additional advantages by using Gen AI, making sure whatever system we have built or which we are going to build in the future, it is better than which we are building right now, right? So Gen AI can be used there. We are still not sure how it can be integrated, but yeah, there are some research going on, and people will be coming out with some kind of solutions, which obviously data engineers will be applying. So we have covered all the 8 points today in this module 1 of data engineering. I hope you would have liked the session. If there are any questions, please do not hesitate to ask, but I hope you have enjoyed the session. Welcome to Module 2 of Data Engineering. Today we are going to talk about the evolution of Hadoop, and we'll start with some of the basic topics and then we'll deep dive into some of the advanced concepts. We'll start with evolution of Hadoop, how Hadoop came into the market. Then we'll talk about what is Hadoop, different components in Hadoop framework, difference between Hadoop 1.0 and 2.0. We'll talk about master slave architecture, explanation of heartbeat mechanism. Then we'll talk about explaining the different components in Hadoop 2.0. I'll then explain difference between ELT and ETL and which one to use, when to use, and which ones the company prefer. We'll talk about some terminology such as OLTP, OLAP, and data marts. These are many times used in the project, so it's better, we talk about them. We'll talk about the difference between on-premise and cloud. And point number 10 also talks about what is cloud, so we'll cover point 10 over here. We'll then discuss about the difference between batch and streaming data. And there are some terminologies which everyone should know, which is SaaS, SaaS, then PaaS, PaaS, and IaaS, which is IaaS, right? So these topics we'll discuss one by one. Hope you like the session. If any topics is left over, we'll continue with those topics in the next session. So let me take point number 1 and let me discuss evolution of Hadoop. So for this, let me open my paint and I'll explain you how Hadoop came into the market. Okay, let me take a straight line. So 2003, I think it's not visible, right? Let me expand it. 2003, then we have 2004, 2006. So 2003 is basically the time when Google came up with a concept called GFS. What is GFS? People ask me a lot of time. GFS talks about Google file system. So Google was the first company to publish a paper, a research paper on Google file system. It talks about if one machine is not sufficient to hold or store all of my data, so it's better, store that data in multiple machines or a cluster of machines. So Google file system was the research paper. If people are interested, they can read about it. But yeah, GFS is the concept or the research paper. Google file system is what we talk about. Google File System. So Google was the first company to publish a research paper in 2003 talking about a concept where if the data which is being stored in a single machine cannot be stored in a single machine as the data keeps on growing, right? So they have researched this paper. 2004 was the time basically when kind of Hadoop framework came into the market. So Apache was the first company who developed Hadoop, but I think around 2004 Yahoo implemented the GFS research paper, which was published by Google. So Yahoo email, if you remember, was the only, I think, email domain where people used to, receive or send emails initially. So Yahoo utilized GFS framework or the research paper, and they have implemented it, and they built up a concept called as HDFS. HDFS. And HDFS 1.0 came into the picture. So I will discuss about what is HDFS, how it came into picture, and what was, the things it was developed. So Google came into the picture in 2003, then Yahoo. Then I think around 2006, Apache, which is an open source company, it collaborated with Hadoop to come up with the concept of Apache Hadoop. So Hadoop is a framework for big data technology. Within Hadoop, you have different things like HDFS 1.0 for storage. Then we have MapReduce for processing as an engine, and then we have Yarn as a negotiator. So we'll talk about all these things in detail. So I just wanted to give you a roadmap like how things came into the market. So 1990s we were seeing a lot of terminologies around big data, but in 2003 the first research paper was published by Google. We called it as a Google file system. Implementation of that paper happened in 2004. So that implementation we call it as HDFS, Hadoop Distributed File System. It's a implementation of Google file system. Yahoo was the company to implement this, so they were able to successfully implement HDFS. 2006 is the time when Hadoop framework came into the market, and Hadoop consists of different things, which we'll talk about, in much more depth. So let me open my notepad, and I'll explain all these things once again. So 2003, GFS came into picture. It's a research paper published by Google. It talks about storing data in cluster of machines if the data cannot be stored in a single machine. So 2003, this GFS paper came into picture. 2004, implementation of GFS took place by Yahoo. Yahoo was then email top market leader. Basically, most of the emails which were sent or else received were through Yahoo. So they implemented GFS. They came up with a concept or framework, I can say, the concept called as HDFS. If someone asks what is HDFS, it stands for Hadoop Distributed File System, right? 2006, Apache company, they came up with an open source technology called as Apache Hadoop, and they collaborated with HDFS. Basically, they collaborated with Yahoo to use HDFS. If I talk about Hadoop 1.0, it consists of HDFS plus MapReduce plus Yarn. HDFS 1.0, initially there was only HDFS and sorry Hadoop 1.0. Initially, there was only HDFS and MapReduce. Later, Hadoop 2.0 came into picture. There we had HDFS plus MapReduce plus yarn. Basically, some of the power of MapReduce was given to yarn, but yeah, we'll talk about it in detail. So this was the way Hadoop came into the market. Basically, whenever there was a need, a new solution comes into practice. So in order to process the big data, a framework called Hadoop came into the picture, and this framework was developed by Apache. Apache is a company, and they collaborated with Yahoo for their HDFS tool technology. So Hadoop framework internally has HDFS mechanism, right? So we talked about evolution of Hadoop, how it evolved, and what is Hadoop. So Hadoop is basically a big data framework. We'll talk about what is Hadoop. It is a big data framework. It is used to store and process big data to provide feasible solution, right? That is the meaning of Hadoop. It's a framework basically. This framework internally has three components, right? Depending upon if it is Hadoop 1.0, Hadoop 2.0. So if it is 2.0, we will have HDFS, MapReduce, and yarn, right? It's a framework basically which is used to process the data and store the big data so that you can solve any big data problems and come up with a solution, right? Now we'll talk about the different components in Hadoop framework in detail, difference between Hadoop 1.0 and Hadoop 2.0. So for that, let me open my paint again. Okay, let me know if you're able to see my screen. Hadoop 1.0, Hadoop 2.0. So we have HDFS, distributed file system. So it's called as a distributed file system because it is, an implementation of Yahoo on their file distributed file system, which is DFS. So Yahoo implemented GFS and came up with HDFS. HDFS was combined with Apache Spark to come up with Hadoop 1.0. So this is called as Hadoop distribution file system, right? So Hadoop 1.0 has Hadoop distributed file system and MapReduce. We'll talk about it again. So I'm just explaining the major components. Here we have same HDFS, then we have MapReduce, and then we have yarn. Okay, what is HDFS? So, for example, we have a huge file. Let's say it is around 3 GB file, right? So it is difficult. Let's say it is a 100 GB file, or let's say it's a big file, and I can't store and process it in a single machine. So my Hadoop framework says, okay, you need not store this entire file on a single machine. You can basically split it or divide it into blocks, right? Split it or divide the file into blocks and store them in different machines. So my block size is basically 64 MB in Hadoop 1.0, and here my block size 128 MB. So in Hadoop 2.0 my block size is 128 MB. In Hadoop 1.0 my block size is 64 MB. So what is block size? It is basically the capacity of each block to store the files. Okay. So if someone asks me how many blocks are there in this particular, you know, machine, or how many blocks are there sitting on this machine, the formula is number of blocks equal to file size by 64 MB, which is the size of each block, right? So number of blocks is equal to the size of the file, basically how much size it is, divided by size of each block, which is 64 MB. This is nothing but size of each block in bracket 64 MB, right? Similarly, the formula will be same over here. Number of blocks equal to file size by size of each block. Size of each block is 128 MB, right? This way, whenever a file is given to me, depending upon the size of the file, first it calculates the number of blocks, and depending upon the number of blocks, we have to come up with the number of nodes, based upon which the blocks will be fed into the number of nodes, right? So this is called HDFS. It's a distributed file system. What is MapReduce? MapReduce is a kind of engine, which is used to process my files. HDFS will only store my files in a distributed fashion, but MapReduce is an engine which will run uh, in behind scenes, which will run some map and reduce jobs. So these jobs are kind of jobs which work on key value pairs. So on just overview, I just want to talk about like my HDFS will help to split the data into different blocks. Each block of file will be sitting in some machine which we call as node, right? My MapReduce now will be processing the split data files which are sitting in different nodes, and when all the files are processed, finally it will be submitted for aggregation, right? Which we call it as a reduce. So MapReduce is nothing but an engine which is used to process my files. Hadoop distributed file system is only to provide me the storage. Now someone will ask me what is the difference between Hadoop 1.0 and Hadoop 2.0. So the difference is initially MapReduce used to assign the task to different worker nodes or different nodes. Basically it will take care, okay, which worker node is free, which is overloaded. Let me try to reduce the work from an overloaded machine to a less overloaded machine, right? All this task was initially assigned to MapReduce, but slowly the scientists understood like MapReduce responsibility is very high. Let me try to reduce it because obviously performance is going down. So they gave some of the responsibilities of MapReduce to another term which we call it as yarn, right? Let me explain what is yarn. Yarn stands for yet another resource negotiator by ARN. Okay. So yet another resource negotiator. What does this mean? Let's say today you have three machines. The data increased. Initially, there were three machines which are storing different blocks of data. The architecture, or the basically, we'll discuss about the Hadoop architecture, how it is happening. Who will decide how many worker nodes are required, or how the files are split into different nodes, or who will decide whether I need some additional worker nodes? This all decision is take place by another component of Hadoop, which is called as yet another resource negotiator or YARN. Coming days in current technologies, we are seeing YARN, Mesos, Kubernetes as a kind of manager or a negotiator to provide us the resources. So that is a major difference between Hadoop 1.0 and Hadoop 2.0. So if someone asks me in the interview, what is Hadoop? So Hadoop is a big data framework which is used to store and process my big data. To store the data, we have HDFS. To process the data, we have MapReduce. And the difference between Hadoop 1.0 is versus Hadoop 2.0 is basically Hadoop 1.0 only has HDFS and MapReduce. Some additional responsibilities of MapReduce was given to another component in Hadoop 2.0, which we call it as YARN. YARN means yet another resource negotiator. It is helping us to, tell basically when additional resources is required or not, depending upon the size of the files. This is called as difference between Hadoop 1.0 and Hadoop 2.0. Now let me go back to the notepad. So we talked about what is Hadoop. It's a big data framework. We spoke about the different components in Hadoop, which is HDFS, MapReduce, and Yarn. And also I spoke about the difference between Hadoop 1.0 and Hadoop 2.0. So now let me go to the third component, which is very, very important concept in big data engineering. Let me draw it once again. So the concept itself is called as a master-slave architecture. Master-slave architecture. I hope my screen is visible. If not, let me zoom it a bit. Let me increase the font size. Okay, master-slave architecture. Many a times people will ask, okay, how the data is split between the different nodes. So we have a master node and we have worker node or slave nodes, right? So I'll talk about the architecture first, right? So this is my master, capital M, master node, right? And these are my worker nodes. So worker is basically slave, right? In previous terminology. So these are my slaves or worker nodes. Worker nodes. So master node can also be called as name node. I can write here master node or name node or parent node. One and the same, right? Here it is slave node or worker node. We also call it as data nodes or child nodes. Let me expand this. Right. So this is a master node and these are my child nodes. Let me take this as 1, 2, 3, 4 and 5. Right. So let's say I have a file which is a huge file. Let's say we are in Hadoop 2.0, which is the latest one. We are in Hadoop 2.0. So if I talk about Hadoop 2.0, we will have HDFS for storage, MapReduce for processing, and Yarn for resource negotiator. Now let's say I have a file. I will calculate the number of blocks, right? Number of blocks is nothing but the total file size by 128 MB, right? Depending upon that, I'll get the number of blocks. So now each blocks will be stored into 5 different data nodes. How they are going to save or how they are going to store is, so the formula is basically number of blocks is equal to, it is not number of blocks, I can say number of nodes only directly. Number of nodes is equal to file size by 128 MB, which is the standard size of each blocks. So the total file size by the by the standard size of each block will give me the number of nodes. So let's say for example we got number of nodes as 5, right? Now the blocks of each file will be stored here in 5 different machines. So my master node is the parent node, or you can call it as a name node. It will see which worker is working on which block of file, how the worker is working. If the worker performance down, master node will be notified. Based upon the notification we receive on master node, my yarn will study, okay, something is wrong. Let me give some another resource where the child node or the slave node is not performing well. Or if the performance of all the 5 nodes is down because the file size is increasing incrementally, then I can assign some other nodes which is given by yarn, right? But yeah, this is the way a master node will see which worker node is working on which block of file. Let's say I have some 10 blocks of file. Let me draw a table. Let's say we have block 1, block 2, block 3, and block 4. These are 4 different blocks of files which are stored in these nodes. Let's say block 1 is stored in number 2, 3. Now people will ask me why it is stored in 2 different nodes. Let's say now node number 2 is down. but I have still my block 1 stored in node number 3, which can be recovered from node number 3, right? If in case my block 2 is down. So similarly, let's say block 2 is stored in 1, comma 4. Block 3 is stored in 2, comma 5, right? Each node will be storing some 2 blocks of file, right? I'm just giving an example. So what is this? Why we are storing each block of file in different nodes? This concept is called as replication factor, RF. So replication factor by default is equal to 3. Basically, each block of file, you will see 3 different copies of the same block of file, which will be stored in different machines, right? Whenever one of my machine is down or when one of the worker node is down, I can retrieve that file from some other worker nodes. That is why replication factor is very much important in the industry these days. So we have understood master and we have seen how master nodes and worker nodes are arranged, how different blocks of files are stored in different worker nodes. Now let me also explain you the heartbeat mechanism. You know our heart is basically beating. So heartbeat how many seconds? It is 70 seconds, right? 75 beats in a minute in a human being. Similarly, my worker node has some kind of heart. You can just assume like the worker nodes send signals to master by some electrical impulse. Okay, these signals we call it as a heartbeat. In science we call it as a heartbeat. Here the frequency is every 3 seconds. Every 3 seconds my worker node will send some kind of signal to master. Basically it will tell, okay, my worker node is alive. It is 3 seconds or 30 seconds. Every 30 seconds, sorry. Every 30 seconds, my worker node will be sending some signals to master. Let's say after certain time, my worker node has stopped working because of some malfunction. So generally the worker nodes are made up of cheap commodity hardware. Why we use it, we are not sure, but many a times we see that worker nodes stop working. Obviously, the reason is it is made up of cheap commodity hardware. Master nodes, very rarely they stop working. But yeah, so secondary backup, if a worker node is not working, the files whichever is stored here, I'll try to grab it from different other nodes till the time worker node 1 is replaced. Okay, so for every 30 seconds, my worker node will send a signal to master. Let's say something happened with worker node number 1. For 30 seconds, it did not see a signal. Next 30 seconds, it did not send a signal. Master node will get alarm. It will see, okay, my worker node is down. I want to see which blocks of file is being is affected. So I can see block number 2 is sitting on worker node number 1, and block number 4 is also sitting on worker node number 1. So basically B2 and B4. I will see, okay, B2 is also sitting on 4. So I can fetch B2 from 4, right? And I can fetch B4 from 5, right? Till the time my worker node 1 is revived, or till the time we have some alternate for worker node number 1. So master data, basically master nodes, or not data, master node will have kind of metadata. This metadata which will tell which block of file is sitting on which machine. Many a times when a client computer, so let me assume this as a client computer. Okay, I can write it as client. Whenever client requests, okay, I want to process a file, please give me the final result from block number 2. I'm just giving you a random example. So my client will talk with master, okay, I want to see the output of block number 2. Master node will have a master metadata. This is a metadata. It will see block number 2 wherever it is sitting. So B2 is sitting on 1 and 4. 1 and 4. Let's say 1 is down. So I can get the data of 1 from 4 and 5. Okay. And B2 is also sitting on 4. So I can rely on these two worker nodes. So master data has this metadata which it will read through to see, okay, which nodes are the worker nodes. Basically, my blocks are sitting on which nodes, and master node will ask, okay, hey, worker number 4 and 5, I want to process block number 2 Please process it and give it to me because the client is requesting. So this kind of architecture is called as a master slave architecture or parent child architecture or name node or data nodes architecture. So this mechanism, wherever the worker nodes is sending a signal to master node, we call it as a heartbeat mechanism, right? This mechanism happens for every 30 seconds. Till 2 cycles, master node will see, okay, if the worker node is not sending any signals, it means it is dead. I need to revive it or I need to, get another alternative for this worker node. Till that time, I have replica of data which can be used from different other data nodes, right? Now someone will ask me, hey Aditya, what if master node is gone? How will I fetch another master node? So the scenes are very rare. Let's say there's a power failure or there's a server down. If a master node is, not giving us the prompt signals, what we try to do is we try to revive it first, right? If the master node is still not revived after doing, update or patch, if the master node is still not working, I'll come up with a concept of a secondary name node. This is called as a secondary name node. This is primary name node. This is secondary name node, SNN. SN, I'll write in caps, SNN, which is basically secondary name node. What it means exactly? If my master node is down for a certain reason, and if I'm not able to revive my master node, I have to go towards a secondary name node, right? So how my secondary name node understands my master node is down? There is a kind of a feature called as a lock mechanism. There is a lock in between master node and secondary name node. So whenever a metadata is stored in master node, the same copy of the metadata will be stored or maintained in secondary name node. So what happens is basically whenever my master node is down, secondary name node also receives some kind of signals from master node. Whenever my master name node is down, or my name node is down, or my master node is down, there will be a lock which will be opened by which basically there's a lock. If the lock is open, basically secondary name node will take place of master name node, and secondary name node will now communicate with all the different worker nodes or data nodes, I can say. So first thing first, we'll try to revive the one which is lost. Basically, we'll try to do a patch up or we'll try to restart the system if my master node is able to work. If not, we'll try to go towards secondary name node. We'll try to open the lock. Name node is nothing but a backup node for us. So that lock once open, my secondary name node will become my master node, and then again it will function as a master node only. So whenever this secondary node becomes master node, there will be another node which will take place of the secondary node. Basically, we need to give another hardware or another server or a system which will act as a secondary name node, a backup for the previous secondary name node, which is now acting as a primary node. So I hope you have understood the architecture of master slave. Master is a parent, slave is basically worker nodes or child or data nodes. The parent will only have metadata which will tell which block of file is stored in which node, right? My data is actually stored in the worker nodes or data nodes or slave nodes. My metadata is stored in master node. So master will communicate with different nodes to fetch the data depending upon the client request. So whenever a data node is not sending signal for more than 2 cycles, then master data will see, okay, there's something wrong with the data node, let me try to replace it. So till the time it is being replaced, we are fetching the data from different other nodes where the block of files are being saved. That concept we call it as a replication factor, right? And if suppose my master node is down, I'll try to revive it by sending some signals or by doing a force restart or by sending some patch up. If my master node cannot be revived, I also have a secondary name node, which is a backup node, which still has a copy of metadata. This copy of metadata is being updated time to time and it is also maintained in secondary name node. So if my master name node is not working or my master node is not working, I'll try to use my secondary name node for the timing purpose. So secondary name node becomes my master node here and then we'll arrange another hardware which will act as a secondary name node. This is the concept of master slave architecture. I hope you have understood it. If you still have any concepts questions, please ask me freely. So there is another concept which I think many people talk about relating to replication factor, which we talk about as fault tolerance. So what do you mean by fault tolerance? What does it mean? So basically, every file which is being stored in a big data environment, you need to have a backup of those files. Let's say today you are storing some data in Chennai server. You also store the data in Delhi server and Mumbai server. Why? Because let's say in Chennai some floods happens, right? Many a times we have seen some floods or cyclone happening in Chennai. Let's say something happened in Chennai, then I won't be able to, fetch the data from Chennai because there is no power or there is no internet connectivity. So in that case, I have to rely upon some other data center as a backup for the same data. So if Chennai is not working, I'll go towards Delhi and I'll fetch the data. Obviously, time will be more because of the distance, but yeah, I am still able to get the data. So fault tolerance is basically a concept to fetch the data by having a backup mechanism, right? My system becomes fault tolerant when we have more number of backup mechanism. It is crucial, very, very crucial, because if my data is lost, it will be a huge impact to the company, right? So I need to have backup mechanisms in place so that if server A is down, I can directly go towards server B or server C or server D. This concept is called as fault tolerant. Whatever system you design, make sure the systems are fault tolerant. This concept is very much asked in the interview. Please try to understand it, right? Let me go back to my notepad. So I have explained you the master slave architecture and how the heartbeat mechanisms work, right? Now I'll talk about the different other components in Hadoop 2.0. Let me go back to the Hadoop screen, right? So in Hadoop we also have other different components such as, let me write over here, we have Hive, we have Spark, we have Scoop, we have Pig. So we have a lot of other components also. So let's discuss overview of each one of them. I don't want to go in depth because these are not used anymore by the cloud technologies. But yeah, some basic information is still required. Yeah, except Spark, most of the things are not being used so much in the market. But yeah, Spark is very much used. I'll talk about Spark in depth. But yeah, we'll go one by one. So what is Hive? Hive is nothing but an open source data warehouse which is built for Hadoop environment. MapReduce jobs in the backend, everything is working on Java, right? The processing part for MapReduce happens in Java. Now the scientists came and the engineers were sitting together. They were thinking, okay, why do I need to write so many complex lines of code to run the big data jobs? Why cannot I write some SQL queries? So they understood, okay, you can still write SQL queries instead of writing those complex Java code. You can do it by, writing SQL queries, wrapper class. So Hive is nothing but a wrapper class on top of MapReduce. Basically, you write all the SQL queries on Hive. In the backend, these SQL queries will be converted to Java and will be fed into the MapReduce machine, right? So it becomes very much easy for me as a developer when I'm writing the SQL query. I need not write the 1,000 lines of code. I can still code 100 lines of code in SQL. Convert in the backend, these SQL queries are converted to Java complex language, which is fed to MapReduce machine, right? So Hive is a data warehouse or a wrapper class on top of MapReduce. We write SQL queries. So the SQL queries which we write is called as HQL. HQL means Hive query language. It is similar to SQL, just they name it as HQL. Some syntax difference, but yeah, you'll be writing SQL queries in the backend. These queries will be converted to Java language, right? Now, what is Spark? People have realized, okay, if we use this kind of components, HDFS, MapReduce, Yarn, MapReduce jobs are very, very slow. It takes a lot of time, right? Instead of MapReduce, industry went towards Spark. Spark was again developed by Apache framework, Apache company. That's why they call it as Apache Spark, right? So, if someone asks me what is Spark, let me open my notepad again. Spark. It is general purpose in memory compute. The difference between MapReduce is, if someone asks you the difference between MapReduce and Spark, so in MapReduce, you are reading from disk and writing back to the disk for each and every compute. Basically, for each line of code, I'm reading the data. For each line of code, I'm reading the data from the disk, processing it, and writing it back to the final disk. This is MapReduce, and that is why MapReduce jobs are very slow in the nature. But why Spark is so much of important? Why do you read or why do you see Spark everywhere? Because everything is happening in memory. All the storage, all the processing happens happens in memory, reducing the seek time or basically input output time, right? That's why Spark is fast. That's why today's Hadoop 2.0 we will have HDFS, Apache Spark, and we will have Yarn as a negotiator. It can be Yarn or Mesos or Kubernetes depending upon the company. These are all resource management tools. It will tell you okay how many resources are required. Dynamically it will increase your cluster size depending upon the size of file is required to be processed. Right? Let me go back to the point. Spark is general in-purpose compute engine. Instead of MapReduce slow job, I will use Spark because all my storage and computation will happen in memory. How is the data warehouse? Well, I'll be writing SQL queries. All the queries, whatever I write, is converted to Java code in the backend, and it saves a lot of complexity from developer because we are writing all the code in SQL and which is converted to Java in the backend. Scoop is a technology which is used to transform the data from on-prem to from one layer to other layer. So you can assume Scoop as an ice cream scoop. The person who gives us the ice cream, an ice cream vendor, he takes out a scoop and putting it on a scoop of cone, right? So similarly, in big data, scoop is a terminology or technology which is used to transfer data from one layer or one system to other system, right? It is not used nowadays. We have different ETL tools in the market. This is again a huge time-consuming jobs, and now we are not no longer using it. Then we have Uzi. Uzi is basically to schedule or orchestrate some kind of jobs. Again, Uzi is not used nowadays. I haven't seen much of the job openings around Uzi. Pig. Pig is similar to MapReduce. These are, some kind of compute which will reduce the stress on the engine. But yeah, pigs also these days are not used. So these are different components. Majorly these days we use Hive and Spark only out of all the things. HDFS obviously is being used. All the data which is stored in my big data environment are HDFS files. Hive is still used. Spark is majorly used. No one can replace Spark till date because it has already removed a lot of dependency by removing MapReduce, right? I hope I have answered this question. Let me go back to the next topic, which is I think we have covered, explained the different components in Hadoop 2.0. So we have HDFS, Spark. Instead of MapReduce, we have Spark, and then we have Yarn. Point number five, and I think remaining points we can cover in module three. Right? Let me talk about the difference between ETL and ELT. What is ETL? ETL stands for extraction, transformation, and loading, whereas ELT stands for same extraction, then loading, and transformation. I'll explain you all these things with a diagram because it will be easy for you to understand, right? Let me take a new diagram. You have data sitting in a source. This is my source. Source is nothing but the initial layer from which you need to grab the data, right? And I need to put the data in this target environment. This is my target, right? To bring the data from source to target, I will follow an ETL process. The process is called ETL. So the process is ETL, but the pipeline, if you'll ask me what is pipeline, pipeline is a component which is used to fetch the data from source to target. It's a component which connects at source and it pulls the data from source and syncs or ingests that data into target. When it extracts the data, extraction happens at source. It is extracting the data from source, okay, and it will transform it somewhere in the middle. Transformation will be happening over here somewhere in the middle, and then it will load the data in the target. So extraction, transformation, loading. So where this transformation is happening, these are happening somewhere in the stage tables, right? So this process which connects a source to target, which will extract the data from the source and which will load the data into target, it's called as an ETL, extraction, transformation, loading. Welcome to module 3 of data engineering. In my previous session, module 2, we were talking about ETL and ELT. We left while we were discussing about ETL process. Let me open the diagram again and let me explain it again. So ETL stands for extraction, transformation and loading. The extraction happens at the source side, right? And the transformation happens on staging area or staging tables. Staging area is nothing but an area where you store the data in its raw format, you apply the transformations and you store it in stage tables, right? So my stage table consists of transformed data. So when you ask about transformation, it can be some basic to medium to complex transformations. For example, I want to append zeros in front of zip code. So for example, my zip code is 50072. So if I want to append 00 in front of the zip code, I can apply some transformation. So I will extract the data in its raw format. I will load it in the staging area. In the staging table, I'll apply the transformation as per the business requirement. And finally, I will load the data in the target. This process of ETL is achieved through a pipeline, which we have showcased over here, right? This is nothing but a pipeline. Okay, I'm denoting it by P. So the pipeline is used to connect to source and to target and to staging area. So from source it goes to staging and staging to target. But I'm just showing you the arrow mark, basically the direction from which the data flows, right? The process is called as ETL, right? And now someone asks me what is ELT? It is a simple thing. Again, the boxes remain same. Here is our source, here is our target, and in middle somewhere we will be having our staging. So you can assume that this is our stage area. Source, this is my stage, or you can consider this as intermediate layer. This is my final layer called target, right? So in ELT process, okay, this process which I'm explaining right now is ELT. So I will extract the source data first, extraction. I will load the table in an intermediate layer, okay, loading, and finally we will transform the data before loading it into target. So here in this case, I'm extracting the data, I'm extracting all the data, I'm transforming all the data, and then finally I'm loading it. But in this case, I first load all the data in my intermediate layer. Now, depending upon the business requirement, I need not transform the entire data, right? Though I have pulled all the data here, extracted and loaded it. In this case also, we have extracted all the data and loaded here, but we are transforming all the data. Basically, before loading, we are doing transformation and we are performing transformation in all the data. But here in this case, we extracted all the data because extraction is an easy process and storage costs are very minimal. So I have extracted all the data, I load it in an intermediate layer, and based upon the business use case, I will transform some amount of data which is required by the target. I need not transform the entire data. Transformation is a very costly process, right? It takes compute. So I can pull all the data and now depending upon the business requirement, I can transform it. Based upon the business use case, I can transform it and I can load it in the target. So this process is called extraction, loading, and transform. This process is known as ELT process. Now, if you ask me, companies have both the process ETL and ELT. Initially, companies used to load the data, transform all the data, and finally bring the transform data on the target layer. But nowadays, most of the companies they depend upon the ELT process. Why? You can load all the data on a central repository, okay, load all the data in its raw format, but transform only those data which is required by the business. For example, I have loaded 32 states data of India, right? But I only want to visualize or perform some analysis on Mumbai, for example. So I need not perform analysis on all the 32 states. I need not perform transformation on all the 32 states. In fact, I can bring all the 32 states data over here, perform transformation only on Mumbai. But why did I bring all the data here? Because today we are doing analysis on Mumbai. Tomorrow it can be some other location or any other state, right? So instead of performing all the analysis or transformation of all the data, I will just perform on Mumbai or on the sample data, right? This process is much more flexible because it tries to save the time. Instead of performing the analysis or transformation on all the data, I'll perform it as per the business requirement. So this process saves a lot of compute, a lot of infrastructures and money for the company. That's why ELT process is very much used widely in the market. So I hope you have understood the difference between ETL and ELT, extraction, transformation, loading, extraction, loading and transformation. The ideal use case scenario is, for example, I'll take the same example of a credit card. You swipe a credit card. Let's say you have used a credit card to withdraw some amount in an ATM, right? The ATM has sent out some data like debited amount from the account. It goes to some staging area where some transformation is performed. Let's say some integer number has been converted to decimal, right? The transformed data is then thrown to target. Here in this case, we have transformed all the data because it's money. And but in ideal scenario, we only transform the data which is for that particular use case or for a particular locality. Let's say this ATM is in one particular location. I only want to study the data of that particular ATM. So I'll fetch the data of all the ATM, but I will only transform the data of that particular ATM which is nearby my locality where I have done the transaction. So that example I can give you for both ELT and ETL. So I have explained the difference between ETL and ELT and which one to use. So these days companies rely on ELT process as they can only transform the data which is required as per business use case. This saves money in terms of compute, resources, time, etc. Right? So this was what I wanted to explain about ETL and ELT process. Both are one and the same, but depends upon how we go forward. How we take the process of loading the data in the target, right? So in ETL we transform all the data, but in ELT we load all the data, transform only certain part of the data, and then load it in the target environment, right? Let me go to the next topic, which is different terminologies: OLTP, OLAP, and data marts. So what is OLTP? This is very much important. I want to build a strong basement for you guys. It is called as online transformation process, sorry, online transactional process. Online transactional process system. OLAP stands for online analytical processing system. So, based on the definition, OL means online transactional processing system. What is transactional process system? This system captures live data and they are used for capturing the recent transactions. They cannot maintain huge amount of history data, right? Example, we can take an example, database, any database. OLTP stands for Online Transactional Processing System. This system can only capture the transactional data, which happens on second to seconds, minute to minutes, or hourly basis, right? Why they are useful is because the transactional data database cannot hold all the history data or all the past data. Why it cannot hold? Because of the size constraint. This OLTP system is not useful for storing history data because we are not doing any analysis on it. We are only capturing the transactional data to understand where or when a particular transaction has been made, who has done this transaction, and at what timestamp this transaction has been made, right? To understand who did the transaction, when it was done, where it was done, to whom it was done. All these details are stored in an OLTP process. For example, swiping your debit card in supermarket. So once you swipe your debit card, okay, it will store information such as the card has been used to perform a transaction where at supermarket by using your debit card, it was done by you because you are using your debit card, right? And the timestamp exactly when that transaction was done, to whom it was done, basically towards the supermarket, and what was the amount. Amount is also there, so I'll write amount here, right? So all the transactional data, basically all the live data or hourly based data is captured in an OLTP system. Now you will ask me, hey Aditya, then why we are using OLTP system? So basically, all the data from different OLTP system flows to OLAP, which is online analytical processing system. Analytical itself means it is used for performing some analysis. So example is data warehouse. So what is a data warehouse? I'll explain both database and data warehouse in depth because when someone is working on data engineering, they need to understand and connect, okay, why data warehouse is used. Okay, so different OLTP system, basically different database data is captured in one data warehouse, is captured in one online and analytical processing system. Why it is captured is because we need to store the recent data till the history data of all the transactions. You cannot store all the history data in your OLTP system. Once certain timeline is crossed, let's say 1 month or let's say bi-weekly data is crossed, all the bi-weekly data is moved to this data warehouse. So you flush it and you fill it in your data warehouse. So all the history data is maintained in a data warehouse. Again, it depends upon the company to company how much history they need to maintain. But yeah, the history data for all the different OLTP system is maintained in a data warehouse. Modern data warehouse are Teradata, then we have Synapse, right? You can use different data warehouse depending upon the requirement. Data warehouse will be helping the Power BI reporters or Tableau reporters, basically any BI engineer, to give you the history data. By studying the history data, people can create a kind of visualization to see how the company was performing before, where the company is performing now, where are the profits or where it is seeing losses, all those things, right? So that's why my OLAP system is basically used to store history to till date data, year to date data, basically from history to year to date, and it is basically required for performing the analysis, right? That is the meaning of OLAP. I hope OLTP and OLAP make sense now. In a pictorial format, I can showcase like this is my OLTP system. There are different OLTP systems, let's say OLTP. This is also one OLTP system, online transactional processing system. OLTP is nothing but a database, right? And you have a data warehouse, right? You can connect different databases in a data warehouse. This is nothing but a data warehouse, which is an OLAP system. These are my DBs, database 1, and this is my database 2, right? I'm moving the data from database 1, database 2 to my data warehouse. This data warehouse will store all the history data from, let's say, 16th of January till last 6 months of data. Now, once the company realizes, okay, the 6 months of data has crossed, I'll flush all the 6 months data from this data warehouse and move it to some other data warehouse. So, data warehouse is used for analytical purposes to, you know, produce Power BI reports or any visualization reports. We also have something called as data marts, right? Data marts are kind of a data warehouse. Data mart 1. This is data mart 2. So data mart, what is data mart? Data mart is a kind of a data warehouse which is used to store the functional area related data. For example, HR, if I want to perform some analysis on HR data, but data warehouse will have all the functional data, right, belonging to HR, IT, operations, sales, etc., etc. But if I suppose if I want to build a chart or a report only on HR data, then I can fetch all the history data of HR over here in data mart 1, all the sales related data for all the sales representative in data mart 2. Because I only want to perform analysis on HR and sales. I don't want to perform analysis on IT. So I can build different data marts which are similar to data warehouse. It's a small scale data warehouse with respect to a particular functional area, right? These are called as data marts. And finally, the Power BI reports. These are the reports which are built by using these data marts, right? Different reports you can build. These are called as Power BI reports. Cool? Understood? So this way, all these things are interrelated. So database can only store month level data. More than that monthly, we cannot store data because it again depends how much scaled up the database it is. Uh, but yeah, if the database size is very huge, again, performance wise, it will give us some trouble. So we don't maintain a huge history of data. We usually we transfer all the data which is in history to a data warehouse. So this is a diagram which I wanted to discuss so that people who are studying data engineering in depth knows about all these tools or technologies or components before we go ahead. So I have talked about difference between OLTP and OLAP system and what is basically data mart. Now let's understand the very much important concept on-premise and called cloud. We've been discussing about different things, OLTP, OLAP. Now I also want to discuss about difference between on-premise and cloud. So people might think, okay, why I'm talking about all these, new terms and terminologies? It's because once we deep dive into the concepts, that time you will be aware, okay, this topic was discussed earlier, and that is the reason Aditya is discussing about it now, right? On-premise, and this is cloud. Draw this diagram so that you guys will remember every time when you sit for the interview. Okay, similar diagram over here. So I will explain this concept in a very layman language. On-premise is like own house. Cloud is like rented house. Okay, point number one is clear. I'll explain again in depth. We need to maintain and perform all the activities by ourselves. We need not perform all the activities by ourselves. It depends upon the amount of responsibility shared. I'm just writing the points initially and I will discuss again in depth about each and every point. Okay? Flexibility is less, high flexibility, more security, I can say more privacy because it's my own house, less privacy because I can expect my landlord to come anytime at any point of, at any hour, so privacy will be less. More security because I'm the only person living here. There is no, neighbors in this house. But yeah, in a flat, in a rented house, top floor might be given to someone, bottom floor can be given to someone. So security wise, it will be a little bit less, right? Little bit less. What is on-premise? On-premise is like owning a system by yourself. Okay, you have to update it. You have to, uh, you know, ensure the proper functioning of it. You have to provide all the patches for it. You are the sole responsibility of that system. It's like my own house. In my own house, I need to take care of my own house. Basically, I need to clean it. I need to maintain the neatness of it. I need to paint it. I need to do the washing and everything. I need to take care of everything. So own house means the entire responsibility is on me. But when I talk about cloud, cloud is a system or a machine or an enterprise given by a third party company. Let's say Amazon, Google, or Microsoft, right? So when they give us a service, so cloud is a kind of a service. You can host your data on a machine which is provided by cloud. You ask them any service like storage or processing, they give you those services, but they charge for it. As you go or offer them, the charges might increase, right? So cloud is like a rented house, depending upon what I want. They're going to give me that service and they're going to charge for it. For example, if I take 1 BHK flat, the rent will be for 1 BHK flat. If I take a 2 BHK flat, the rent will be for the 2 BHK flat. So depending upon what I want, the rate I have to pay from my own pocket. So it's like a rented house. And here the responsibility will be very less depending upon how much shared responsibility is given to me. So the landlord can ask me, okay, you can stay here. I will give you all the services like electricity, water, and everything, but you need to pay the water bill and the electricity bill. So some kind of responsibility is given to you, but yeah, the maintenance of the house, painting, pest control, everything else will be done by the landlord. You need not worry about it. But yeah, the some aspects of it you have to take care, like for example, paying the electricity bill, paying the water bill on time. That is something which you need to take care. So in own house or in on-premise, you need to take care of everything. But in cloud, some responsibilities are given to the third-party company like Azure, Amazon, Google. So they have their own cloud. Google has GCP, Amazon has AWS cloud, and Azure is from Microsoft, right? On-premise flexibility is less. I have to stay there. I need to make sure I am there because I'm taking care of everything. If I go somewhere, something might happen on my behind or on my back. So I, flexibility wise, it is less. Cloud, since it's a rented house, I can lock it and I can go anytime because obviously there are some other people who are staying there or there are neighbors, right? So security wise, flexibility wise, flexibility is high, obviously in a rented house. Own house means I cannot directly sell away that house very easily. Rent means I can just pack my bag, clear the rent, whatever I had to pay, and I can go to other house. But if I have my own house, I cannot leave my own house and go to other house easily, right? Whereas if I'm on a rented house, if I don't like something, easily I can go from one cloud to other cloud, right? So flexibility wise, flexibility is more in a rented house, which is nothing but cloud. Now let's say privacy. Consider you have a duplex home, duplex house. Ground floor is given to other family. Topmost floor is given to some other family. Privacy files, do you think that there will be privacy? I don't think there will be privacy, right? There will be sounds or noise or some other kind of disturbance. Same thing which happens in a PG. In your own house, which is on-premise, security and privacy will be high because no one else will be intervening with your activities. Whereas in cloud, since you're staying with some other people whom you don't know, whom you don't have trust upon, privacy issue will be there, security issue will be there. So that's where cloud gives you different kind of services again. Within cloud, you have different types of cloud. Public cloud, you have hybrid cloud, and then you have private cloud. If some government company wants to host their private data on a cloud, which again is accessible by that government agency only, that should be stored in private cloud. You cannot use hybrid or public cloud. Private cloud is very costly because the third party company will take care of all the privacy and all the security of the cloud. They could have used the on-premise, but yeah, they cannot perform all the activities by themselves. I mean, they cannot give all the activities to other companies, right? Because it is on-premise, it's our own house. So I need to spend additional resource to work upon them. Instead, I'll only spend those resources to work on them only when there are some work required, right? Otherwise, I need not pay for it. So that's the difference between on-premise and cloud. On-premise is like my own house, cloud is like the rented house. So I hope you will remember this difference whenever you sit for the interview, right? Let me go to the next topic, which is so we discussed about ETL, ELT, the different terminologies like OLTP, OLAP, and data marts. Just now we have discussed about on-premise and cloud. Now let's talk about batch data and streaming data. Before I talk about, we also discussed about cloud. Cloud is nothing but third-party companies which are offering their services to different clients or companies which they can use based upon their requirement. So what cloud? Cloud is it? It's like a machine which you cannot see in cloud basically, which you cannot see as a, I mean, these are virtual machine. These are huge, huge, big data centers. Sometimes they're so big, like they dip those data centers into the ocean, right? These data centers are storing huge amount of data, and each data center is maintained across different locations across the earth or the geographical locations. So clouds are big machines which are owned by these big companies, which provides different services like storage, compute, depending upon what type of compute you want to do. They give different kinds of services, and now it depends upon the companies which service they need to take. Obviously, just using the service for a particular duration of time, I just need to pay for that time. Instead of maintaining the entire infrastructure at my own company, I can only use those services. For example, if you don't have laptop, right? Or if you have a laptop but you don't have a program to run on your laptop. So what you can do, you can go to cloud, buy the resource to do compute, and perform all the necessary calculations or analysis required on the cloud. Pay for those particular duration of time, perform a complete your project, and then once project is completed, close the account because your work is done. Instead of buying a new laptop, you could have rented the cloud for a few weeks to complete your project, right? This is nothing but cloud, right? I have answered question number 10. Let's go to question number 8, difference between batch data and streaming data. Difference between batch data and streaming data. So what is batch data? So data warehouse. So data warehouse stores history data, right? When you move, when you want to move the history data of a company, let's say last 2 years, 3 years, 4 years, you cannot bring all the data at once, right? Because these are huge, huge volumes of data. To bring that data, we need to bring that data in batches, right? So let's say you have last 3 years of data. I can bring 1.5 years of data at once, or I can bring 1 year of data at once. So I'll bring 2021, 2022, 2023. I'll bring it in this fashion, right? In different batches. So either you can do this, right? Or you can go a bit more granular. I can bring 6 months data in one batch, right? So similarly, I'll build a different pipeline to get or fetch 6 months of data every now and then, right? So batch data is used to pull or bring or fetch data, which is mostly history data, right? Because the volume of data is so high, you cannot bring all the data at once at a time, right? You need to bring them in batches. That's where batch data processing is used in big data. So wherever you need to bring history data for some analysis, then you need to bring that data in some kind of batches. Why? As the volume of data is high, you cannot bring all the data in one shot, right? Since the data volume is so high, you cannot bring all the 3 years of data in one pipeline or in one shot because the GBs of the data will be so high. You might be, you know, create a pipeline which might fail or whose performance will be very slow, or you might try to corrupt the data which is present in the source. So that's why batch data comes into picture where I'll be building pipelines. I'll build pipelines in such a fashion that it will bring the data in samples, like 6 months of data or 1 year of data, and it will load in the target area. So the next pipeline will bring me the last 2 years of data. So first pipeline ran the last 2 years back of data. I mean the third year's data from the last. Next pipeline will bring me last to last year's data, and the last pipeline will bring the last year's data. Right? This is called as batch processing to bring the history data. Now what is streamline? So example I can take to study my performance in school in last 2 years of schooling. If I want to see how I have performed in class 9 and class 10, I need to bring last 2 years of data. Obviously, I'll bring the data in batches. This will tell me, okay, I have performed in this way 9, 10, 10, and then based upon that, which study or which subject I need to choose, right? This is called as batch data. Now, what is streamline data? To fetch the real-time data or near to real-time data, we need to bring the data and process it so quickly so that we can give uh, advice or recommendation accordingly. Here I can take one more example. Example, Amazon. It will study. It will study the history of your purchase, and it will give you recommendations based on that, right? So what is streamlining data? So in order to fetch the real-time data or near to real-time data, we need to bring the data and process it so fast so that I can take some decision or I can give some recommendation accordingly. For example, FIFA World Cup was going on. I have fetched the data and understood, okay, these many users are watching the channel. Now, if I want to increase the storage capacity or, if I want to increase the number of machines so that users can still log into the OTT platform to watch that particular channel, I need to study the real-time data. Basically, how many users are entering into the application. So I want to study that. So this fast data which is flowing, basically in every second or in every minute, some users will be logging into the app. If all the users logging are logging at the same time, then the app might crash, right? For example, same Amazon. So they want to study the real-time data, like how many users are entering into the app, how many are trying to purchase. So I want to increase the number of machines in the backend so that my app or my functionality of the app will not crash, right? So to streamline or to fetch this latest data or live data or near to real-time data, I need to have a pipeline to fetch the real data or near to real-time data. This pipeline is called as streaming data. The pipeline which fetches this live data is called as streaming pipeline. It is not streamlining, it is streaming. By mistake, I've written streamlining, it is streaming data. So batch data is used to bring history data. Streaming data is used to bring live data or near to real data. Another example is I can give you is, for example, let's say there is a disaster and I need to give an alarm to all the people living in a particular area. For example, Japan. Japan, there will be a lot of earthquakes or volcano activities. So in case of such disaster, I need to alarm the public in a very quick fashion. So basically, there are some sensors or IoT devices near the earth, basically near those epicenters where usually those activities happen. I need to capture the data, process it, and understand, okay, whether this is a data, real to near time data of a live earthquake. If yes, I need to capture the data quickly, process it, and trigger the alarm so that people will understand, okay, we are going to see an earthquake, so that they can take proper measures depending upon that data. So to fetch this fast data, to process it, we need streaming pipelines. This is the difference between a batch data and a streaming data. Streaming is for fast moving data. Batch data is for data which can be moved slow, right? Hope you have understood the example. You can take example for controlling traffic. Suppose traffic is very high in one particular area, let's say Koramangala of Bangalore, is seeing a lot of traffic. So I'll fetch the real-time data, like how many vehicles are stranded. Okay, I'll try to see, okay, which road near to this road is empty. I'll try to regulate the traffic by diver diverging the traffic in that area. Basically, I'll stop the vehicles incoming and I'll move or divert them to some other area. That is also an example of streaming data, right? I have think I have covered this answer. Now let's move to this difference. It is very important. We'll cover this in the explanation now. Okay. SaaS, software as a service. We have PaaS, platform as a service. We have IaaS, which is infrastructure, infra. So, what does each definition mean, right? These are all concepts of cloud. I wanted to cover it because down the line when someone is talking about all these terms, people know okay what we're talking about, right? SaaS. SaaS means software as a service. Example, Microsoft Suite. Whenever a person is purchasing Microsoft Suite, they will get Microsoft Outlook as one of the softwares, right? It is an inbuilt Outlook software. It is an application or a software, I can say, inbuilt, which everyone uses to send emails or to receive emails, right? It's a part of Microsoft Suite, obviously. Similarly, Microsoft Excel, it's a software which people usually use. It is again a part of Microsoft Suite. All these companies like Microsoft, Amazon, Google, they have a lot of softwares which they offer as a service. Basically, they'll give you all these applications or software which you can buy obviously on a yearly basis. So you will receive a key by using which you can access these tools, right? Or these softwares or applications. So any company which is offering the software or application as a service for which you need to pay or on a yearly basis. So those tools or technologies or applications what you use are called as softwares and it is given as a service by these companies, right? So I hope you have understood it. Example I can write Microsoft Outlook or LinkedIn. LinkedIn Premium is a software as a service. LinkedIn free version, you don't see that many things, those many prospects of it, but yeah, Microsoft tool, LinkedIn Premium is basically software as a service example. Platform as a service. I can give you the best example is Azure Cloud. Azure Cloud. Okay. So what is platform as a service? Azure is a huge cloud. Basically, it gives you a platform of different services. Now, if someone wants to use Azure Cloud for storage purpose, they can use a particular feature within it, right? Azure Cloud is a huge platform. Within it, we have different services. Let's say for storage, you have ADLS service, right? For creating a pipeline, you have Azure Data Factory. For transforming your data or for performing some read activity on data or making some high transformations, you can use Azure Databricks. For streaming analytics, you have Azure Stream Functions. You have Power BI within Azure. You have Azure Data Fabric. So there are a lot of things within Azure Cloud, which is a platform where you can utilize any service based upon your need or requirement, right? Platform is basically it's a combination of different services. Azure Cloud is a combination of different services under one single platform, right? So software as a service will be one particular service within a platform. But PaaS stands for Platform as a Service, SaaS stands for Software as a Service. Within a platform, there will be multiple softwares as a service, right? Example I have already given, like Azure Databricks, Azure Data Factory. These are all different softwares as a service. Depending upon the usage, how much data you are using, you have to pay for that. But you can buy all these different applications under one umbrella, which is called Platform as a Service. IaaS, Infrastructure as a Service. Example, all the data centers. Example, best example I can give you is the data centers. I can write here. So the data centers is basically those big machines which stores all huge amount of data. So Azure has its own data center located in different geographical locations. They can give you the entire infrastructure as a service. Basically, they can give you one host server, resource group. Basically, they can give you a management group. Within management group, there are different subscriptions. Within subscriptions, you have resource group. Within resource group, you have multiple resources. So basically, they're giving you a very big data center called as an infrastructure. You can utilize your infrastructure, which is given by Azure for your own use case. You need to think how you need to use this infrastructure for your own specific purpose. Within infra, they'll give you all the required things like firewall, architecture, how the data has to be stored, you know uh, those things they'll give you in that kind of advice, but how you need to use the data, where you need to store the data, what all different applications you need within this infrastructure, all this decision comes to you only. It is not maintained by the company. They'll just give you the infrastructure. Okay, this is the architecture, this is the infrastructure. Now it is up to you how do you use it. So if I think okay, there's too much of responsibility, I can directly go for a platform. But if I have to maintain the entire infrastructure of my company on a third party infrastructure, I can directly buy their infrastructure and then design according to my needs, right? These are the different terminologies which we usually see in Azure Cloud. which is SaaS, Software as a Service, IaaS, Infrastructure as a Service, and PaaS, Platform as a Service. So I think I have covered almost all the topics of my module 2. Some of the topics which were left out were covered in module 3. We'll go to the next topic, which is data locality, and we'll start discussing our topics upon Azure Data Factory, okay, why it is used, and components of Azure Data Factory. So before I talk about Azure Data Factory, let's talk about data locality. Basically, it talks about where the data is stored and where it is processed. Usually, in big data world, we process the data where it is stored. So we don't move the data towards the compute. We move the compute towards the data, right? So what does data locality mean? Data locality means I want to understand where my data is being stored and where it is being processed, right? So if suppose I have very huge amount of data, I cannot move all this data to a particular compute. Initially, yes, this was the way it used to process, right? For example, in my computer, I have hard disk. All my hard disk data will be fed to CPU for processing. But these days, big data amount of data is so high, I don't want to move the data towards my compute. Instead, I'll move my compute towards the data where exactly the data is residing. I need not move in the other way around. Basically, I will not move the huge chunk of data towards the compute. So data locality talks about a concept where I'm storing the data and where I'm processing it. So I will store the data in any location, but I'll move the compute towards that location so that the processing will happen exactly in the same place where the data is stored. So it's a very important concept in big data engineering. I hope you will remember it. So data locality usually means storing the data and processing it wherever it is stored. So let me see if we have additional time so that we can start about Azure Data Factory. I think yes, we still have time. What is Azure Data Factory? We'll try to cover here. So Azure Data Factory is an ETL tool or data cloud data integration tool. It is used to fetch the data by building pipelines, comma, by connecting various sources to targets, by performing simple operations or transformations. Okay, we can also orchestrate our pipelines in Azure Data Factory, right? So what is Azure Data Factory? Azure Data Factory is an ETL tool or a cloud data integration tool. When I talk about cloud data integration, it means I want to integrate different source data, right? Integrate as in I want to aggregate or integrate or combine all these different data setting across different places. How do I fetch this data from which is setting in different places? I try to bring a pipeline. I will build a pipeline which connects the different sources to a single target area, right? That's where I am going to integrate all these different data which is sitting in silos. So Azure Data Factory is a tool which is used to pull the data from different sources to a particular target. How do we do it? We build pipelines which connects different source connectors. So we have around 99 source connectors, right? We also have around 99 plus target connectors. So we connect to different source and target by using different connectors. We call them as link services. We'll talk about them. And by using these different connections, we try to pull the data from source and then we load it into target. This is the main tool usually used in Azure environment to pull the data. And there's not much coding involved. It's a low to no code tool basically. There are functions involved obviously, but yeah, ADF is basically done on a UI. Like, it's very easy. If you learn this properly, the chances of you landing a job in Azure data environment is very high, right? So I hope you have understood what is Azure Data Factory. Azure Data Factory is an ETL tool which is used to fetch data from source to target, right? Now I'll discuss about the components of Azure Data Factory, like different components in Azure Data Factory. We'll talk about many. I'll be talking about the main points or the main components in Azure Data Factory. Tomorrow in Module 4, we'll be discussing about different components, different concepts under Azure Data Factory, and then we'll try to build one project also in depth. So different components are link service, dataset, integration runtime, pipeline, activity. So what is link service? Link service is a kind of a connector. Okay, it helps us to connect the pipeline to a source. Similarly, it will help us to connect the pipeline to a target. For example, let me take a diagram. This is my source, this is my target. Okay, I am building a pipeline to fetch the data from source to target. This is the pipeline, right? Now, this is a link service. Basically, it's a form which you will fill to derive a connection between the source and the pipeline. So, for example, once you let me take an example of an Amazon delivery guy. Okay, delivery guy asks, works on a link service. Delivery guy will pick up the order from warehouse, come to your home. This is your home. This is the, let's say this line is the warehouse, or let's say this is a warehouse. This line is your home. Delivery guy will come here and he will try to authenticate whether it is you who have purchased. So you will share OTP on your phone to the delivery guy. Say that okay, this is the item which I placed as an order. This is the OTP. Please deliver it to me. So basically, you are communicating with the delivery guy so that you can connect with the warehouse order which you have received. So in the same way, in order to connect my pipeline with source, I need to fill out a form which I call as a link service. I will give I'll give the information such as host server name, some connectivities, all these things I need to fill out in a form. Integration runtime, whether it is a auto resolved integration runtime or it's an SHIR, right? The password, user ID, all these things I fill it out on a form, which is used to authenticate the connection between the source and the pipeline. Similarly, I'll use another link service here to connect my pipeline with the target. So for different sources, we have different types of link services, right? For now, I think we have 99 types of different link services, but yeah, the numbers might have increased. There are, I think, 100 plus now connectors which can help you to connect with different source. So let's assume this is one source. If we have another source over here, the link service might change. You cannot use the same link service to connect this source with this target. You might have some other link service, right? So link service is used to help us generate connection between the pipeline and the source or between the pipeline or target. It is used to authenticate the connection. Now what is dataset? Dataset will tell you the type of data or the structure of the data which you want to extract. For example, if you are fetching a CSV data, the data type will be CSV. If you are fetching an Excel data, the data type will be Excel. If you are fetching JSON data, the data type will be JSON. So when you're creating a link service only, basically if I want to pull out my source is basically a CSV file, right? In my link service which I create, there I have an option to define the data set. There I will see CSV as a data set. I'll show you when you're talking about how to create a pipeline. We will discuss that in depth. Similarly, if I have an Excel as a source, I have Excel file as a source. I need to bring this CSV file to target. I need to bring this Excel file to target. So to connect my pipeline to CSV, I'll fill out a link service, which is a form. I will talk about what all details you need to fill in this form. But at the data set, I will select the structure of the data which I want to pull in the format of a CSV. Similarly, I'll select the structure of data in the format of an Excel, which is called as a data set. So depending upon the different type of file you're loading, if it's a JSON file or it's a XML file, you can select different data sets. Again, there are 99 plus data sets. The number might increase, but again, yeah, these data sets are part of link services. And it tells us about the kind of data or the structure of data which you want to pull. Integration runtime, basically, they are powerhouses or fuel for our pipeline. They provide resources for compute. Basically, they're powerhouses for a pipeline. Basically, it provides the energy for the pipeline to go and pull the data from a source and then load it into target. So there are different kinds of integration runtime. We will talk about it in the further classes, but I want to give you a generic overview. What is integration runtime? Pipeline is basically this diagram which I have shown. Pipeline is a component which is used to pull data from a source and load the data in the target. Finally, activities. There are different activities which will be, talking about while building a pipeline. So for example, to pull the data from a source to target, I have one activity which is called as copy activity, right? It will copy the data from a source to target and load it. So there are different activities which we'll be talking about in depth while talking about Azure Data Factory. I wanted to discuss this point. So some random activities are copy activities, okay, for each activity, then lookup activity, store procedure activity, then we have web activity. These are different activities which we'll be using going forward to design the pipeline, to orchestrate it, and to use it. The other component is basically trigger. It's not a component as such, but I can still write about it. Triggers are used to schedule the pipelines. Again, there are different types of triggers, which we'll discuss again in the next classes. I think in the module 4. But yeah, triggers are used to schedule my pipelines. Once a trigger is scheduled, my pipeline will be activated or my pipeline will start running on those particular scheduled times. So I think I have covered most of the part as a basic of Azure Data Factory. We'll cover the remaining things in the next lecture, which will be module 4. But yeah, I have covered all the topics of module 3, and we will deep dive into Azure Data Factory, how to create a pipeline and all those part in the next module. Welcome to module 4 of data engineering. Today we're going to give you a walkthrough of the different components of Azure Data Factory. We are going to open ADF Studio and then we'll walk through the different components on the UI. Then we'll talk about Azure Integration Runtime, what exactly is integration runtime and different types of integration runtimes. Then I'll delve into the basics of Blob versus ADLS Gen 1 versus ADLS Gen 2, how these things came into picture, right? And then we're going to talk about authentication. What are the different methods of authentication which we use in the real-time industry, and what is authorization, right? We're going to take all these examples and we'll then walk through different concepts. Let me open Azure Data Factory Studio. You can see I have opened this link portal.azure.com. You can directly click on this or you can go and click on home. So this is the page on which you will land. So portal.azure.com is maintained by Microsoft Cloud, right? So you can see different components over here. If you want to open storage account, you can click here. If you have Data Factory, basically, if you want to launch the Azure Data Factory Studio, just click on this. We have already created one Azure Data Factory Studio. I'm just going to click on Launch Studio, and this is the ADF Studio where we are going to create all our pipelines, orchestrate them, schedule them, and run them to copy or ingest the data from different source to target. As you can see, ADF B4 Lab. So it's basically Azure Data Factory. We have given some kind of name, calling it as lab. I'm going to give you a walkthrough of different components which you see on the screen. This is the home button, which will be landing you on this page. Pencil icon is nothing but author button. If you click on that, you can see different ADF resources, basically factory resources. Here are different pipelines which you have. You can see all kinds of pipelines which we have created earlier. I can give you a random example of a pipeline, but yeah, let me first give you a walkthrough of different components. CDC is a newly developed concept. It stands for change data capture, basically to understand any changes within the source system. If you want to see those changes, we can track it by using Azure Data Factory. It's a new concept, but yeah, we can still do it. We already discussed about datasets. Datasets tells us about the structure of the data. If you're connecting it with any source system or any target system, you need to have different kinds of dataset based upon what type of source you're using or what type of target you're using, right? Data flows, again, data flows is something which we are going to discuss, but yeah, it's not majorly used in the industry. It is used to perform very simple to small transformations, something like a filter option or aggregate options, right? Small transformations can be performed by Azure Data Factory, but usually we don't do it because whenever we go for data flows, it's going to spin up my Spark cluster. And this, the cost which we are getting from Spark cluster on Azure Data Factory is comparatively high when compared to Azure Databricks. We can also connect our Azure Data Factory to Power Query, and that option is also here. If you see, this is a plus icon. If I click on that, I have different kinds of resources which I can use. I can create a pipeline. I can create a change data capture preview. I can create a data set, and I can create a data flow, right? I'm not going to create anything. I'm just trying to give you a walkthrough of different components we have. On my right side, you can see all the symbols. These are basically the updates. Azure, Microsoft usually keeps on updating the tool now and then whenever there is a patch or whenever there is an update. So you can go through updates, weekly, or you can just, go through it whenever you find time. But yeah, these are the updates which you see, which is released by Microsoft. I can close it. You can see you can switch data factory. I have currently used one of the data factory, but yeah, you can switch it. Notification. You'll get notification when basically you're publishing your pipelines. For now, we don't have any notification because we are not publishing anything. Going back, these are the settings. Basically, if you want to perform some settings, you can convert your theme to default view or a dark view, depends upon you. Again, if you need some help, you have Azure Data Factory documentation, which you can go through it. If you're facing some error from Microsoft side, you can connect to the team from Microsoft and raise a concern. All those things are available. There is feedback also. Obviously, if you have any feedbacks or improvement, you can obviously give your feedback. Uh, Let me cancel this thing, right? So this exactly is author icon where you can deploy or develop your pipelines. Uh, Let me create a pipeline. We'll name it as pipeline underscore test. When I have named it, you can click on this icon, properties. So basically, my pipeline underscore test will be created. If you can see, this is my pipeline underscore test. Now I can pull in different kinds of activities. We have different kinds of activity. Copy data is one of the majorly used activity. It is used to copy data from source to sink. So I can select wide variety of sources, right? I can select a data source. It can be CSV. Let me select any data source in CSV format, right? This is a CSV file which I'm going to dump to a sink. I can select a sync dataset as delimited text file. Taking one CSV and I'm dumping the same file in CSV formats in other location, right? If I go to mapping, there's no mapping required. But yeah, source, if I click on open, the dataset is already configured to a particular link service, right? And if you can click on test connection, it's going to tell you if connection is possible. Let's see if it is working. It is testing for that particular connection. But yeah, you first need to create a link service, then you need to create a data set for that particular link service. Give the path also. Basically, where are you trying to pick up your file from? So you have a path, source container, subfolder is list of files. Within that, there is an input file in txt format. Right? I'm going to close this. In the sync also, I have one dataset which is in delimited format, which is a CSV. I'm going to open it. Again, file path is basically source container, source, and .json file. We're going to, load it in the format of a JSON file. Let me do the test connection, and connection is successful. So basically, if I debug pipeline, debug is basically will tell you how my pipeline is working in the background. You can see copy activity is being performed. I click on refresh. It will take some seconds of time, but yeah, once the copy activity is completed, we can go and check if the file has been placed or not, right? So I can see source, open, source container, list of files is the folder. There is a source container file path. We have to see where this container is, and within the folder list of files, it will pick up this file, right? And it is going to dump in same source container, another folder is there, source, and in JSON format it is going to place. So let me go and see my pipeline. Just click somewhere. My data activity is running. Let me refresh it. It is still running. We'll wait for some time. So copy activity is the majorly or famous used activity in Azure Data Factory. We are going to see what all it has within it. We are going to still consider and build big pipelines, basically complex pipelines, which will help you to understand a lot of things in going forward. So let me go to home. I'll open one of the storage account, or let me go to home and see the container basically. Okay, I need to go to storage account first. Directly I cannot open this container. Go to storage account. Let me see if this is available. Go to containers. I think it is already moved. What? Let's see. Source container. We have picked up one file from. Let me go back. Source. Open dataset. We picked up a file from list of files folder, right? Let me go back. So list of files folder. So this file, we picked up this file, okay? Source container, go back, and we are dumping it. Let me close this. We are syncing it in folder called source, and the file is web.json. So folder called source, and the file is web.json. You see, today's date, 23rd of Jan 2024, I got the file. So the same file was already present. Since it is present already, it is creating another file name, json2.json. So, okay, we gave the name as json2 only, so it is creating a file called json2.json. It keeps on overriding the files, right? It will override the previous file, but yeah, you can see and track it based upon the date, right? So this way, my Azure Data Factory helps us to, ingest the data from different sources and helps us to sync it or put it or load it in different target systems. So I have shown you the author icon. Basically, it will help you to create multiple pipelines, complex pipelines. I'm going to give you much more examples in the future classes, but yeah, this is a basic pipeline which I wanted to tell you, right? So this is a monitor button. I can monitor all the pipelines over here. I did not put any triggers as of now, but I can see my last debugged pipeline. So the pipeline which I ran recently, you can see the job run ID of that particular pipeline, how much time it took to execute, what is the starting time and what is the ending time and the pipeline name. If I click on the pipeline, you are able to see the same pipeline which I ran, right? So let me go back. So make sure you don't publish anything because I don't want to create or save the changes. I can click on refresh. So we talked about monitor. It is used to monitor the pipeline, monitor if the pipeline has passed or failed, also to check if my pipeline is still running, or to check if there is some dependency of some other job on this pipeline, or to check if the pipeline is running at the scheduled interval of time, right? If a pipeline you're debugging it, basically you're just running it in normal mode by clicking on debug, so it will be shown over here. But if you have already scheduled a pipeline, it will run on a particular time interval, right? On a triggered, basically scheduled interval. So there you can go and click on triggered, and you can see all the pipelines which you have triggered automatically. So this is the monitor tab. Now you can see this briefcase icon. If you click on that, you will have different types of things over here. Let me give you a walkthrough of different things, what we usually view or what we usually use, right? Link services. Link services is basically a kind of connection which is used to connect to different source system, target system, or different any kind of connections, right? It is used to connect my pipeline with some kind of connections basically. So there are around 99 plus connectors. It can be CSV connector. I mean, link service again depends upon different kind of sources. So if I click on use link service, you can see the different wide variety of link services Azure Data Factory has. So I think as of now, there are around 99 plus link services. You can use, I mean, there are like 99 plus connectors in link services. You can use any of them for Amazon S3. It depends, like depending upon what type of source you are trying to connect to or what type of object you are trying to connect to, there is different kinds of link service. So try to select any of it. Let's say I select Amazon S3, click on continue. So you can see the name is Amazon S3. Automatically, by default, the integration runtime which is chosen is auto resolved integration runtime. You can change it to SHIR or some other type of integration runtime. It's up to you, right? And then each kind of source will have different type of connectivity. So for Amazon S3 bucket, it's a kind of storage layer. It is asking for the URL of Amazon S3 bucket or where exactly you're going to store your data. And to authenticate the connection with this S3 bucket, you have access key, right? So this is one of the things. If I want to directly connect to Excel, if I write Excel over here, Azure file, database. So in Azure, you can click on Azure file storage, click on continue, right? So basically it is asking for the storage account name where your file is placed, right? And the file share. If I select any storage account name, for example, so there is no file share. File share is basically if you have any method to share this file. So as of now, we don't have anything, but yeah, let me go back and change to Azure Blob Storage, click connect and see what it's trying to give. Okay, so here I'm trying to connect a pipeline to a source which is nothing but a blob. So there are different types of authentication types. I'll discuss them right now in some time. But yeah, authentication type is one of the way to check if the user is authenticated or if the user is genuine or if the user is valid or working within the company premise. So it can be a user or device or any system. So authenticating whether the person is working within the current company or not. So there are different ways of authenticating a particular user or device or a system. We are going to talk about it. And these different subscriptions, you can go for a free trial for 1 month by using a credit card. But yeah, if you want to, if you have expired your free trial, you can go for pay as you go. I'll go back and show you like there are a lot of connectors which you can choose, and depending upon that, you can schedule or you can activate your link service. So for now, I'm just going to cancel it. I have already created few link services, and you can see the related number of times it has been used. 13 is basically the number of pipelines this is calling this particular link service. So 13 is basically number of pipelines which is calling this link service. Each target copy is being called by 21 kind of pipelines, right? We have integration runtime, right? Integration runtime is basically a compute for our pipeline. It is basically, I would say, a fuel to run all our pipelines. It will give the compute to the resources, right? Microsoft Purview, it is something new. It is basically connecting Microsoft Purview to Azure Data Factory, and it will help you to check your data across different environments. So it's something new. Again, there's a lot of research or POC being done. Git configuration. This is to configure Git CI/CD mechanism to your Azure Data Factory, because whatever we release, whatever pipelines we develop, to go through or should go through a particular CI/CD process. So we develop the pipeline, then we move. We develop the pipeline in a feature branch, then we publish it to a master branch. From master it goes to QA, from QA to prod. So it flows in that way, right? So that is enabled in a Git configuration. We have ARM template. Anything which we create, anything which we publish is stored in an ARM template, and that is basically used whenever we deploy our code from lower to high environment, right? Triggers, a very important concept. So basically, whenever you want to schedule your pipeline, then you enable a trigger on it. You create a trigger and you tell the pipeline, okay, this is the time when your pipeline is supposed to run. There are different types of triggers. Again, schedule trigger, tumbling window trigger. We are going to discuss that, but yeah, as of now, just remember triggers are basically used to schedule your pipeline. We have some global parameters. So many times, whenever we are creating a pipeline, you need not hard code the values within the pipeline. You can call it out over here within global parameter, and there you can pass it as a parameter. You can pass those parameters. The parameters that will come here and read the value from global parameters, right? Data flow libraries, we are not going to use much of data flow, so it's okay. These are the different things which we have in this manage component or manage icon which you see over here. It's like a briefcase icon. Learning center is something which will give you different videos, tutorials, or quick overview for the tool. Now let us go back to home. Let us click on author. We have seen this copy data activity. I have orchestrated a file to copy it from source to target. We have seen that file. So I'm just going to refresh it. I don't want to save my changes. If I want to save it, you can click on publish all. Validate all is basically to validate all the resources if everything is fit and fine, right? You can click refresh also. You can also track this pipeline on ID. You can either go and monitor from here, or you can just click these three dots. I'll show you again. These dots you can click, and you can click monitor from here as well. You can see debug. It won't show under trigger, but it will show under debug, right? So I don't want to save this pipeline. I can just refresh it. Let me do it. Refresh, refresh, right? So my pipeline, whatever I have created, it did not save back in the Azure Data Factory. So whatever save changes we will be doing, it will be on our local repository or my feature branch. I have to publish my pipeline once it is completely created to a master branch, dev master branch. Master branch is somewhere where all the developers will be working together. And once all the developers who are working in that master branch complete the sprint, the pipelines, whatever is completed as per the business requirement, they are going to move to low to high environment. So from dev, it is going to move to QA. So release team, basically there are different release teams who are working within the company. They will download the ARM template and they will publish it from dev to QA, right? So it goes to different CAB approvals process. It goes to CI/CD mechanism process, which I think most of the companies follow. This is the major thing which I wanted to cover. So you can try your hands on over here. You can also search the different data factory components from here as well, right? I have shown you different things. So storage account, we have already seen storage account is basically, it can be type of different kinds of storage account. It can be blob or ADLS Gen 1, Gen 2. We have already created one storage account. I'll just click on that. Go to data lake storage, ADLS container. and this is the file which we have here. So I'll explain now in brief. Let's go to the next point. I think it's a good time to talk about first about we'll come to integration runtime in a later stage. Let's first talk about AD Gen 1, AD Gen 2, and blob. So let me write here. So first let's talk about blob. BLOB. What does blob stand for? Blob means binary large objects. So when Microsoft was developing Azure Cloud, the main intention of having cloud is to store different types of file. It can be audio file, text file, semi-structured, unstructured, or structured files. It can be any kind of file. So to store small files which are not in semi-structured or in unstructured format, binary large objects as a storage layer came into picture, right? So advantage of having these features as storage is basically they are highly scalable. So advantage will be like they are highly scalable. I mean, they can be scaled up, and cost of storing data is very less. So that's one of the advantages of using blob. So first, Azure came up with the concept of blob, but the problem with blob is there is no hierarchical namespace. Basically, if I open drive, let's say I have opened C drive, right? Within that I have programs folder. Within that I have some other folder, let's say games. Then within that I have some other folder like 2024 games, right? So I have different folders which is present in hierarchy. So this type of feature is not available in blob. But there is a concept called virtual container, virtual folder. This came, I think, 2.5 years back. Virtual folder is blob helps us now to come up with this kind of hierarchy, provided my ultimate folder or my last folder has a file. So 2024 should have some file. Let's say road rash game, road rash dot, let's say CSV. There's one file which has cheat code. Okay. So this file should be present in 2024. If this file is deleted, then there won't be any folder structure being maintained. Blobs directly can save the files within one blob or within one binary large object. But if you want to have a hierarchical namespace or this kind of structure, you need to have one file. So this kind of folders, what you're trying to prepare is called as virtual folder. As soon as I remove this file, my entire structure or this folder won't be remaining. All the folders will be deleted, right? This is called as binary large object. Now, what is the difference? So Azure then came up with the concept, okay, every time I have to create a folder and then place a file, let me have something called as ADLS. It stands for Azure Data Lake Storage. Azure Data Lake Storage. So data lake is a place where you can store any kind of data, which can be structured, semi-structured, unstructured. I have already discussed the advantage of using a data lake when compared to data warehouses. You can store any kind of data, and the storing is very easy. You need not try to prepare the schema. So it's basically schema on read. Schema is prepared when you're reading the data. It's not schema on write, right? And the other thing is Azure Data Lake Storage is very cost effective. The cost of storing your data is very minimal. So that's where Azure Data Lake Storage is used. And last benefit which is missing out in Blob is hierarchical name space is enabled. The major problem what we had with Blob is basically hierarchical namespace was not enabled, which was solved when we are using ADLS. So basically we can maintain some folder structure. Let's say Aditya is a folder. Within Aditya there is a Bengaluru folder. Within Bengaluru I have some folder like college. Within college I have folder certificates. And within certificates I have different certificates like 10th, 12th. So even if I delete these files, my 10th, 12th certificates, my folders will not be eradicated or it will not be dissolved. I will still have these folder structures which are being maintained. So this is called as Azure Data Lake Storage. So there's again a difference between, so ADLS again are of two types, Gen 1 and Gen 2. Azure Data Lake Storage Gen 1, Azure Data Lake Storage Gen 2. Currently we are using Azure Data Lake Storage Gen 2. Now a very good interview question is basically they will ask you the difference between Gen 1 and Gen 2. What I have discussed right now, this thing is Gen 1. Okay, and Azure Data Lake Storage Gen 2 is nothing but Gen 1 plus blob. So basically Azure Data Lake Storage Gen 2 is built on top of Azure Data Lake Storage Gen 1, right? And it also has features of blob. So I can store my files in hierarchical format. If I don't want to use ADLS features, I can still have blob features where once the file is deleted, all this folder structure will be deleted. But since it has Gen 1 features also, I can store all the kinds of files which I'm storing in blob. But yeah, the structures will be still maintained even if the files are deleted, right? That is the difference between ADLS Gen 2. So that is the difference between blob versus Gen 1 versus Gen 2. So Gen 2 is nothing but features on built on top of Gen 1. Gen 2 is nothing but Gen 1 plus blob. Gen 1 is Azure Data Lake Storage Gen 1. It basically has hierarchical namespace. Basically, when you delete a file within the last folder, then the folder structure remains still consistent. Blob is something different. Hierarchical namespace is not enabled. It is used to store binary large objects like music file, JSON file, XML file, or any audio visual files. Basically, it can store any kind of file. But yeah, if you want to enable hierarchical namespace, you have to, make it as a virtual folder. Let's talk about Azure Data Integration Runtime. I think now it is the right time to dwell into that. But before that, I want to show you my home. So if I click on storage account, let me go back to home. If I click on storage account, these are the different storage account, and you can see version 2, which is ADLS Gen 2 or version 2. All these were enabled pay as you go, nothing is free. I can open, let's say, this storage account, and you can see it is having a data lake storage ADLS. If I click on that, there is a container. So basically, a storage account is built on top of ADLS Gen 2. Within the storage account, you have container. I can see here there is a source container, and within that, since it is a Gen 2, these are the folders which are being maintained. Even if I delete one file, delete, yes, deleting the blobs, refresh, no blobs found, go back, refresh. You see the folder is still there even if I have deleted the file. It says no blobs found because it is Gen 2. It is blob plus ADLS Gen 1. Even though I have deleted a file, my structure remains same. The folder is not being deleted, right? So that's what I wanted to show you. Now let's talk about integration runtime. So if you remember, we've talked about what is integration runtime in the previous module. Just understand, like, Azure integration runtime is nothing but a fuel to power your pipelines. So it provides all the resources to your pipeline. It can be compute resource, memory, storage. So basically, if I let me open a task manager. If you open the task manager, you can see how much of resources or storage you are using, how much RAM it is being provided, how much memory is given to each application, all the things you can see, right? Similarly, Azure Integration Runtime will talk about what type of compute resources or what type of resources Azure is providing to your pipeline. So if I go to the official definition, let me show you the official definition. I have PPT over here. If you see the official definition, integration runtime in Azure Data Factory is a compute infrastructure that provides data integration capability across different network environment. So it basically provides all the resources whichever is required by a pipeline. It can be compute, it can be memory, it can be storage, all the things. We have different types of integration runtime. So if in interview, if you're not able to remember a definition, Just understand like it is a fuel to power your pipelines. The fuel can be a kind of a resources as in the storage or memory or compute, right? There are three types of integration runtimes. I will call it as IR. First one, auto resolved integration runtime. Second one, we have SHIR, self hosted integration runtime, right? And the third one is SSIS, integration runtime. This is mostly used for SSIS jobs, ETL jobs, or packages, right? What is auto-resolved integration runtime? Azure understands like whenever a pipeline is created, by default, it is going to give or it is going to assign integration runtime as auto-resolved integration runtime. But what is the reason behind it? So auto-resolved integration runtime is basically used when both your source and target is sitting on Azure cloud, right? When I'm talking about both the resources, basically both the source and target system are present in Azure cloud in a public domain, in a public environment, right? So whenever you want to connect a pipeline, which is connecting a source and target, which is present on Azure cloud, so by default, Azure is going to tell, hey, you don't need some other kind of infrastructure or some other kind of mechanism to give you resources for infrastructure or for compute. So I'm going to give you auto resolve integration runtime because it is already familiar with Azure cloud. Use this as is. This is basically auto resolve integration runtime. It is mainly used when both my source and target is an Azure component or it is sitting on Azure cloud. Then someone will ask me what is self-hosted integration runtime. This is a feature or another kind of integration runtime when either my source or target is sitting on-premise or basically in a private network. It is not part of cloud. For example, if I want to connect to Oracle server, let's say it is not sitting on cloud, I need to fetch a file or I need to fetch data from Oracle server and I want to dump it to Azure Data Lake storage. So here my source is on-premise, basically it is sitting on a private network and my target is on cloud. So if someone will say, why can't I use auto resolve? Because my source is not on cloud, right? I cannot use auto resolve integration runtime. I have to use an integration runtime which can be used for both the types of systems. One is source and target. So that's why I go for SHIR because it is used to connect source and target if both of them are not sitting on Azure cloud, right? Here one is sitting in private network, which is a kind of on-premise environment. We have already discussed about cloud versus on-premise. On-premise is like you're owning your own house. You have to do your own patch updates, all the house cleaning activities by yourself. So the responsibility will be high, flexibility will be less, right? We have already discussed this thing. So this is called as SHIR. Now, if someone asks me, what is SSIS, integration runtime? When do we use it exactly? So SSIS stands for SQL Server Integration System, right? And usually SSIS also is part of Microsoft. Whenever our ETL jobs are running on SSIS, we have a different kind of SSIS integration runtime for those kind of jobs. Since the pipelines are built on SSIS suite or SSIS packages, Azure has developed its own integration runtime, which they are calling it as SSIS integration runtime. So by default, if your ETL jobs are prepared on SSIS SQL Server integration system, go ahead and use SSIS integration runtime. The main agenda of integration runtime is to provide compute resources to your pipeline. So if both source and target is on cloud, auto resolve will be selected. If either one of them is not on cloud or on a private network, use SHIR. If everything is on SSIS ETL jobs, then use SSIS IR, right? I also now want to show, so we have covered integration runtime. I have shown you link service, data sets, activities. Activities is something like a copy activity which I have shown. Pipelines I have already shown. Data flows we'll see in the later stages. I want to explain you this diagram. This is a very important diagram which I think many of the people uh, wanted to know, but yeah, they are not much aware if they are working in the companies. But yeah, I want to give you a high overview of what this diagram means. So within Azure, you will see different services, right? Different kinds of systems or components which you can use. They are called as resources. So you have a database, you have compute, you have server, you have different kinds of things. All these resources comes under resource group. So whenever a new person joins a company, he will be added to a resource group. If he is added to a resource group, he can use all these applications, right? Which are nothing but resources. So different resource group. So resource group is again governed by the project team. You will fall under which resource group. So sometimes all the resource groups of the company or some resource groups of the company fall under one bucket which is called as subscription. And two or more subscriptions they fall under management group. So it is like management group are a group of people which will manage the different subscription. Per each subscription they're going to pay, right? Because obviously when you're using something under Azure, you'll take a kind of subscription. It says like, okay, I'll have so many resource groups, and within these many resource groups, these many resources will be there, and I'll be using it, right? So management group is a leadership team, let's say. Subscription is the kind of subscription they want to use. Within the subscription, we have resource groups, and within resource group, we have different kind of resources, right? So this is what I wanted to show you, and now I can directly jump to integration runtimes, which I have already told you. Auto resolve integration runtime. So you can see the definition. It is automatic integration runtime created and managed by Azure, which I have already explained. Like it's a default integration runtime when data sources and destinations are hosted in public networks such as Azure. Basically, when both my source and target system are sitting on Azure environment, Azure cloud. ADF by default selects the auto resolve integration runtime automatically when creating a pipeline if the data source and destination are compatible with it. We have already discussed. Then auto-resolve integration runtime is compatible with various data sources and data processing activities, such as in ADF you have seen like Azure Blob, ADLS, Azure SQL Database, and SD Insight. I have already discussed all the points, right? What is SHIR? It stands for Self-Hosted Integration Runtime. It basically means you can run copy activities between a cloud data store and a data stored in a private network. Private network is nothing but on-premise, which we have already discussed. Then it uses the infrastructure and hardware managed by you. Since it is on-premise, it's like a own house, right? You have to do all the things by yourself. You take care of installation, maintenance, patching, and scaling, but you also pay the time you're going to use the Azure Data Factory. That also I have discussed. So SHIR works like a gateway. You install integration runtime on a machine inside the private network, and then it can communicate with the ADF. That I have already spoken while explaining. What about SSIS? Azure SSIS integration runtimes are VMs running SSIS engine, and ADF uses SSIS integration runtime for executing SSIS packages. We have already discussed most of the things. I think it's repetitive in the slides, right? I have covered the walking through of different components on Azure Data Factory. We've covered different integration runtimes also just now, and I have discussed about difference between Gen 1, Gen 2, and ADLS, and difference between all these things versus blob. Before I move to authentication and authorization, I wanted to cover one more topic, which is I've already discussed about data lake. I also want to talk about data lake house. So how data lake and data lake house came into picture. We've already discussed Azure data lake storage just some minutes back, right? ADLS, German, Gen 2, blob. So we know like right now what is data lake. Data lake is used to store different formats of file, different structures of file. Okay, it is highly scalable. It can store the data even if the folders are not virtual, right? But one problem with data lake is when different people are using data lake. Let's say around 100 people in the company, if they are using the same data lake, everyone is dumping their data. After a certain time, let's say after certain years, there's a huge amount of data, and then you won't be able to locate where exactly the required data is sitting. For example, I have let's say two department within engineering, right? Let's say one department is working on Salesforce, some other department is working on ERP, and they are using a same data lake where they are storing their files or data. Let's say after some time, after 5 years of time, they have stored so much immense amount of data, and to give you a rough estimate, you can store around 5 TB of data in a storage account. 5 TB of data is huge. So after some time, after 5 years, these two projects within engineering, right? One who is working on Salesforce, other one who is working on ERP, they won't be able to locate their own data. Why? Because they have been continuously storing data in irregular fashion, and now they don't know where they can fetch their data from. So this kind of concept is called as a data swamp. When you're keeping on dumping data without understanding how you can fetch it, that becomes data swamp. So there are high chances your data lake can become a data swamp when it is used by different people over long period of time. Then how do you solve this problem? So to solve this concept, there was a paper or there was a POC done to come up with the concept of data lake house. So data lake house is nothing but a data lake plus a data warehouse. So if you see data lake, there's no house they are taking from warehouse, right? So it becomes data lake plus house, data lake house. So what additional features does this data lake house has? So if you know or understand, my data lake, you're just storing your data. There's not much security involved. There's no privacy or governance which a person has. There are no good amount of access controls also if you're storing your data on a data lake. All these problems were solved when a person moves from data lake to data lake house. So what are the features of data lake house? Number one, you are able to figure out where your data is sitting. This concept is called as catalog, Unity catalog. So it's a kind of a dictionary. Basically, it will tell you in which page I have to go to fetch that information. Basically, it will tell which corner I have to go and fetch the data from. Right? There are something called as indexes, which will help me to guide to that particular page or a location where I can find my data. Right? Now coming to security and privacy, data lakehouse is much better, much robust when compared to data lake because there are a lot of third-party firewalls or security enablement on data lake house. And coming to data lake, there is another feature which is missing, which is called as ACID compliance. ACID properties are not enabled on data lake. Time travel is also not enabled in data lake. You cannot log your files using a data lake. So all these features are enabled in a data lake house. You can log your files, you can do time travel through different times of data, similar to what you have done in the data warehouse. So basically, data lake house has features of data lake, which is nothing but storing huge amount of data. It can be scalable, storing at a lower cost. Plus, it has features of data warehouse, basically asset compliance, then time travel, logging files. So all these things are concept of data warehouse. So that features also is enabled in data lakehouse. Also, you're able to figure out where your data is being stored. So that is one more advantage of using a data lakehouse. That's the major difference I wanted to tell you because we'll be also telling people to go through this definition before they sit for the interviews because many a times people get confused with these terminologies, right? So let us talk about authentication and authorization. Before I'll start authentication, I'll make you understand the definition of it. Authentication, authorization. Authorization is giving authority to someone, giving someone some kind of authority is called as authorization. Basically, giving some kind of accesses or power to do something is called as authorization. There are different types of authorization. You can give authorization by giving them accesses. So there is a read access, there is write access, there is contributor access, which is nothing but read and write and perform some execution, and there is execute access, basically perform action. So there are different types of authorization. Whenever a new person joins the company, he or she raises access, and the company will authorize the user and give them some kind of responsibility that he or she can either view the data or open the data or perform some kind of writes on top of the data, or just execute the pipeline. This is called as authorization. Authentication is verifying or verification. Verifying if the person or user or system or device is part of our organization. So authentication will help us to enable data security, and it will help us to enable or check the connectivity when someone is trying to access the data. So whenever an external person joins the company, or whenever a new person joins the company, we need to authenticate whether this person is actually from our company or not. So there are different ways of authenticating a person or a device or a system who is new to the company. For example, you create a Gmail account, you create a MMT account, Make My Trip account. You can access MMT by using your Gmail. When you click on Gmail, since you are already logged in, it doesn't ask for your email ID and password because you're already part of Gmail. So basically, what user ID and password you are using for Gmail, the same user ID and password is a kind of authentication for MMT, Make My Trip, to allow you to use that portal. Authentication will help a person use or get authority for something. It can be to get access as a read, write, or execute, or do some kind of activity. There are different authentication types, but I think we have covered a lot of things. Let us cover different authentication types in the next class, which is module 5. But before that, I want to take you on Azure Data Factory page again, and I want to show you one more thing. I want to show you the authentication. We go to home. You can see security and network. So here there are different kinds of security network or authentication. Manage ACL is basically access policy. If I click on that, basically how someone can access this storage account. I'm trying to see there's no access policy here. Access keys. Majorly, access keys are nothing but user ID password to connect to a particular storage account. These keeps changing every 6 months of time. So usually we recommend people to not use access keys. But yeah, depends again from company to company, the kind of process they use. Identity access control. So basically, you can control the access to a storage account. This is the storage account, right? Within storage account, we have a container, right? So you can control access of this container by using IAM, Identity Access Control Management. So you can see view my access, what kind of roles you are assigned to, right? You are an admin role. You have basically you can do all the activities which an admin can do, right? Check access, check what all accesses you have. So so you're part of a user group, right? I'll be going to talk about these different things, but yeah, for now, you see all the different kinds of roles a person can have: owner, contributor, reader, writer. So there are different kinds of roles. Again, depends upon the company. These tasks usually are handled by admin team. Our part is as a data engineer is just to raise access request whenever required, right? Data protection. Wanted to cover this topic also. Whenever I delete a file from blob, so blob internally, Microsoft blobs can store or recover the data back to 7 days. If any file which you have deleted and it crosses more than 7 days, even if you raise an internal request to Microsoft, they won't be able to recover it. So it is a kind of a recovery mechanism. Let's say by mistake, if a new team member joins in the company and if he or she deletes a file which is not supposed to be deleted, so you have this soft delete option which you can still recover, right? So blobs, you can recover the files for 7 days. You can increase it, I think, up to 30 days. I'm not sure, but yeah, it is something which admin take care. So containers also, if someone deletes a container, right? We have one notebook. I think it is called as vacuuming notebook. It completely deletes a container. So if you by mistake have deleted a container, you can still recover it, I think, back to 7 days. So in the next module, we are going to talk about a different authentication type, and then we are going to talk what is the advantage of each of it. We have spoken about Gen 1, Gen 2, authentication, authorization. As I said, authentication is verification. Authentication is the process of verifying the identity of user, system, or device. It confirms that the claimed identity is valid, basically tells us whether the person is really working within the company, and authenticates, basically grants them access. Authenticates the user to a system or resource. In simple words, authentication answers the question, who are you? Are you really working for the company or not? Right? Because every access is paid. Company also don't want to waste their money. Since it is a paid access, company wants to give it only to the people who are actually working on it. Authorization is the process of granting access or denying access. When you join a company, you raise access to authorize to do something, right? You're asking some kind of access request, asking like, if you give me this access, I am authorized to perform this task. So this is called as authorization. It defines what actions a user or system can perform once their identity is verified. So to authorize someone, first they are authenticated. If yes, they are able to authenticate, then they get authorized power. We are going to discuss authentication types in the next class because it's something which will take time. But yeah, welcome to Module 5 of Data Engineering. Today we are going to discuss the below topics. First, we are going to discuss about asset properties. Then I'll discuss about the CAP theorem, very much famous interview question which is being asked in the design rounds for data engineering roles. Then we will see or look into delta life tables advantages, and then we will deep dive into the ADF activities, right? So we'll discuss about asset properties. So many a times you might get this kind of question, what is asset properties? So asset basically stands for atomicity, consistency, isolation, and durability. So what is atomicity? Atomicity. Every transactions which happens, I mean it can be any transaction, basically a banking transaction or any normal transaction, whatever happens should be atomic in nature. Basically, it means like either all the transaction is successful or the steps within a transaction is successful or it is not successful. Ideally, to give a best example, let's say I have a bank account and I have transferred 1,000 rupees to one of my friend, right? So atomicity basically means 1,000 rupees being deducted from my account and 1,000 rupees going to my friend's account. It cannot be a scenario where 1,000 rupees has been deducted from my account but did not go into my friend's account, or money went to my friend's account but he did not deduct from my account, basically. Or it can be other way around. Money deducted but did not go, or money went but did not money did not go, but it was showing something like it reached to the friend's account. It means either the transaction is completely successful or or it is not successful. So let's say I have sent money from A is transferring money from A to B. Let's say, okay. So money from A deducted, money did not reach B, money from A not deducted, money reached B. So it means either, so if the money has been deducted, it should have reached B, right? Scenario one. So both of the activities should complete for me to say atomicity is maintained. If one activity is not completed, it means it's not atomic transaction. Case 2, if you see money from A not deducted, then how money credited into B? It can be some from some other source. So if this is not deducted, money did not reach B. So both of the activities should be completed for the money to go from A to B. So any transaction should be atomic in nature. transactions should be atomic in nature. Either all should pass or all should fail, right? If money is not deducted, then money should not reach B, because one is failing, other should not be passing, right? So either all should pass or all should fail. Ideal scenario, actual scenario, I would say, money deducted from A, money credited in B. Other scenario, money did not deduct from A, money did not credit in B, right? These are the actual scenarios for saying my transaction is atomic. So atomicity basically means either all the parts of transaction is completed or successful, or if both the transaction activities are not successful, it means it is failed. So every transaction should be atomic in nature, right? Consistency. What does the word consistency mean? Let us understand. Consistency. So my transactions should be consistent. By the way, why am I using these terms consistent atomicity with respect to transactions? So ACID compliance basically deals with OLTP system. When I talk about OLTP, it means online transactional processing system, right? All these rules apply for a transactional system. So what does consistency mean? Consistency means my transaction should be consistent, or in easy simple language, it should comply with the constraints of a transaction. Best example, I have 2000 rupees in my friend's account. Okay, I asked him to send me 4000 rupees amount. So as per the transaction, I asked him to send me 4000 rupees, but he only have 2000 rupees, right? Can he send 4000 rupees? No, because 2000 rupees is the only amount which he has in his account. He can transfer the entire amount in case zero balance account is maintained. If you have to still maintain some 500 rupees in the account, he can only send 1500 rupees. So there are some constraints being maintained. So whenever I'm performing a transaction, my database will see, okay, what is the minimum amount to be maintained in that account, and after that how much amount can be transferred. If the amount is sufficient, then only the transaction will happen. So my transactions should obey the law of consistency. My transaction should obey the law of constraints. If it is not obeying, it means consistency is not maintained, right? This is actually called as transaction being consistent. So transaction should be atomic. All the parts of the transaction should complete. Transaction should be consistent. It should obey the rules or the constraints, right? What is isolation? Isolation. Best example I can give is every transaction should be isolated in nature. For example, I spent money in supermarket. Okay, I received amount 1000 rupees from my friend. Okay, at the same time, I was charged 500 rupees for fast tag. Okay, fast tag. So I have spent some money in supermarket. A, this is part A. I received some amount from my friend, part B, and also I was charged at the toll 500 rupees as part C. All these transactions are happening in a serialized manner, right? And these are all isolated. So whatever amount I have in my account, let's say X, right? Initially I spent some amount. Let's say I have spent 2000 rupees. X minus 2000. Then I received some amount. So x minus 2000, I'll get some y value. Then I received some amount, y plus 1000 rupees, right? I got some z value. Now z minus 500 is the total final value which I'm left with, right? Final value amount I have in account. So all these transactions are happening one by one in an isolated fashion. It's not like the money which I'm receiving 1000 rupees from my friend, from that some amount was spent and then that amount got credited. No, all the things are happening in a serialized fashion based upon the timestamp, and then these are all isolated in nature. There is nothing like, it's always like first come first basis, right? And all of them are isolated. This transaction will not be aware of the next transaction happening. So that is called as isolation. One transaction will not know what is happening with the next transaction, whether it will be a deduction or it will be a credit, right? So all my transactions should be atomic, it should be consistent, it should be isolated. So the final word is durability. The transactions happening should be durable or accurate. Basically, I should rely on a principle of transactions that that is safe, reliable, and durable, right? Basically, when I'm putting some amount in my bank account, I should not be worried about that amount. Okay, whether tomorrow it will be lost, or tomorrow because of some transactions happening, the money will not be, sent or deducted from that account, right? So the transactions what are happening should be reliable, should be durable, and only when it is accurate, then only people will be doing, transactions from one account to the other. That is why all the four components, atomicity, consistency, isolation, and durability, basically reliability of the transaction, is very important. And if I go back and search in Google, if you search here, asset compliance, just search asset compliance, and if you open any of the documents, either it is from MongoDB, you can see I have given the same example what is being taught over here. Either everything should succeed or nothing should succeed, right? Consistency is basically database constraint. It talks about obeying the rules or the constraints of any transaction, right? So anything, if it goes beyond, if anything goes beyond the constraints, the transaction is supposed to fail, right? Isolation, because every transaction is happening in an isolated environment. Nothing, one transaction will not know about the next transaction, right? So same example, if you have 200 rupees, you are trying to withdraw 100 rupees at the same time, all these transactions happen concurrently, ensuring that your ending balance is 0, not 100, because transactions impacted each other. Okay, so all the transactions are happening in an isolated environment. Durability is nothing but uh, ensure what happens once the transaction is complete, the changes in the environment. So durable is also basically whenever transaction is happening and if something got failed, you have still a snapshot of each and every transaction being maintained in a database to see the before and after picture of a database, right? Or the amount which you have in your system. Basically, let's say I spent 500 rupees in a supermarket, the amount got deducted and it did not reach out to the merchant, let's say. Because of some power failure, the amount did not happen, the transaction did not happen properly. In that case, the amount whatever has been deducted should be rolled back to my account, because of the asset property, number one, also because of the consistency. Since amount got deducted, it should reach to the merchant. If it has not reached to the merchant, it is somewhere in the middle, right? So it has to be rolled back to my account. So durability is basically reliability of a transaction. So that's why I told you you can go through this document from MongoDB. I have also used it for preparation. Read about it. Basically, what is asset transactions? Why as atomicity, consistency, isolation, and durability is very much important, right? Now let us go back. So I have discussed about asset properties. Now let us talk about the very much important concept which is highly asked in the interviews called as CAP theorem. CAP theorem, I think it was also called as Laplace theorem. Let me see. Brewer's theorem. Why we called CAP theorem as Brewer's theorem? Because it was named after the scientist Eric Brewer. Okay, and every distributed system, whatever you take in the market, should work upon this CAP theorem, right? So many a times interviewer usually ask in the interview what is CAP theorem, why it is very much important. Any system design round, uh, if you are adding this CAP theorem in the concept, it basically shows the kind of approach you have, the kind of concept you have, right? So let us discuss this also. Let's see uh, practically, also theoretically, what CAP theorem means, right? So I'm taking three circles, part of Venn diagram. Here I can write it as consistency. Let me know if it is not visible. Consistency, atomicity, and this is durability. Okay, sorry, this is partition terms. One second. Availability, partition, tolerance. So, big data concept says there is no distributed system where there cannot be any network breakage or network failure or network partitioning, right? Let's say these two systems are connected, they're distributed. I can take one example. Let's say system A, system B, both are distributed systems. Distributed system means it has a worker node, it has a master node, it has multiple worker nodes, right? So let's say there are two distributed system A and B, right? Cluster of machines, I can say. So A is communicating with B, right? So that both the copies A and B, you can just treat it like copies of the data working on two different distributed system or parallel processing systems, right? A and B together are working, to fasten or to quickly process the data. Let's say A and B are mirror images, right? So how is A and B connected? A and B is connected by using some network. Okay, let's think of A and B as connected through a network. Connected through network. So people will ask, okay, why A and B is connected through network? A should know what is happening in B, B should know what is happening in C. Since both of them are mirror images, the final output of A should match with the final output of B. Now let's say in an event, there is some network failure, right? In an event of a network failure, what's happening in A will not be known by B. What's happening in B will not be known by A. Both are now will be treated as different isolated systems, right? Previously, both are mirror images because they have well bound connectivity between them. But now, if the connectivity is broken, A and B will be working as a independent systems. They don't know about what is happening in them. So in that case, CAP theorem comes into picture or Brio's theorem comes into picture. What does CAP theorem states? In an event of a network failure or even in an event of a network partition, why I'm saying the word partition? Because the network has been partitioned or divided. In an event of a network partition, I can either maintain consistency or availability, but not both. Let us now understand this sentence. First, I'll write the entire definition, and then we'll explain. I'll explain you basically what it exactly means. In an event of a network partition, basically a network failure, we can either maintain consistency or availability, but not both. What exactly it means? Let's say when there was a good connection between A and B, any transaction happening in A will be somewhere be reflected in B also. Let's say today there's an account X which is maintaining 100 rupees. Okay, some 100 rupees got deposited from some other account. So total amount which is now converted is 200 rupees. The same data will be reflected here. X equal to 200 rupees. X equal to 200 rupees over here also, right? Because there's a well network maintained between A and B. So any transaction happening in A will be reflected in B, provided there's a very strong network in between them. So the data, whatever is seen here, is available here. Number one, availability concept is met, and the data whichever you see here is equal to the data which is present here. So both the datas are equal. So it is consistent. So both of them are consistent and available at the same time. But in an event of a network partition or a partition tolerance, I can either choose between availability or I can choose between consistency. So in an event, when my, let me expand this or else it will become difficult to type. In an event when my network is down, I can choose between data availability or data consistency. So what does this mean? It's a very beautiful concept derived by Eric Brewer. So let's say if there's a network partition or let's say the network is broken between A and B. So I can choose whether I just need to show some data in A and B. For example, I'm not concerned with the accuracy of data. I can show, okay, X equal to 200, but B equal to 100. I can show the previous snapshot of B because the user is not worried about the data what they're seeing. Okay, so in case when availability is the priority, I can write here. In case when availability is priority, I will compromise what? I will compromise consistency of the data. Data will not be consistent between A and B, right? Because for me the highest priority, so I just need to show some of the other data. Let's say best ideal example I would say is if suppose a web application is down, okay, and they have some data in it. People are not consuming the data, but they just want to see the pictorial representation of data through a Power BI report. They just need some kind of graphs over there. In that case, they're not much worried about the data which is they're consuming in terms of value, but I mean in terms of accuracy, they are not much worried about that accurate value, but they only want the data to be displayed in the form of chart. In that case, availability of data is much more priority for me than the consistency of the data, right? But now there is another example. In case consistency is important, then availability has to be compromised. It means whenever a network partitioning is happening between A and B, it's okay till the time both the values of A and B should match, right? Till that time, I will not display any of the values between A and B. Best example is your banking system. Let's say a banking system is down. In banking system, consistency is highly important, right? I cannot just show any value to the customer. The customer might be overwhelmed seeing the amount in his account, in his or her account basically. So I should give utmost priority to the data consistency than data availability, right? Because for me, my customer should not be worried about seeing a very lesser value in the account or seeing a very high value in the account. Obviously, when people see a high value, they'll be happy, but I should not compromise on the consistency or the accuracy of the data. So that's a place where consistency is highly important than availability. So it depends upon the user what is important to them, either consistent or data availability. I just need to show some of the other data. I'm not worried about the value or the accuracy of the data. That case, I can just show some of the data and A and B are not equal. Okay, but consistency is highly important till that time consistency is maintained. So when the consistency is maintained is basically when I'm able to generate a network between A and B. Till that time, I will not display any data. I will generate a network. I will generate a secondary network between A and B, right? Let's say once I have generated a network between A and B, let's say I have generated a network between A and B. Till the time the network is generated, I will not show any data, right? But once the network is generated, I'll wait till the time A and B are showing both the values. And once both equal values, and once the equal values are shown, then I will say, okay, my data is now live. You can go and consume the data. This is called as CAP theorem. So there is an event wherever, whenever there's a network partitioning, I can either choose between consistency or availability. So I can have CP, AP, and AC. So let me show you this document, which is on CAP theorem. So CP and AC, you see this diagram, right? Basically this part. Let me take a diagram. Let me take this thing. So in an event of a network partitioning, I can either have consistency or partition tolerancing, CP, or I can have availability or partition tolerancing, right? But if there is no partition tolerancing, basically when I have a strong network between A and B, I can have both availability of the data as well as consistency of the data. So this part is called AC. AC, CP, AP, right? Always visualize this example of a bank account. You need to have a consistent system. Consistency of data is highly important in that case. Availability is secondary, right? Let me see if the recording is happening. Yes, it is happening. So I hope you have understood CAP theorem. Now I will take and will move to the next concept, which is again very much important. So CAP theorem, I can write it is also called as Brewer's theorem. Just writing one liner note so that you can also make a note of it. Uh, in the event of a network failure or network partitioning, I can only choose between data availability or data consistency. But in case I have a strong network, I can have both data availability as well as data consistency, right? This is called as CAP theorem or Laplace LAP. This is also called as Laplace theorem or Weber's theorem. These are like completely interchangeable, but yeah, be prepared, if you're going for a design interview. Cool. Now let us understand delta life tables. Very, very important topic, guys. Usually asked in the interviews. What is delta life table? What is the advantage of a delta life tables? So that there are two types of tables. One is data lake tables. Other one is called delta tables. So any table which is built on top of data lake data is called as data lake tables. If we have some properties invoked which makes it much more robust, much more stronger in terms of performance, in terms of the way it processes the data, then it becomes a delta table. So I'll basically talk about the advantages of a delta table data lake table. First one is asset compliance. So what is asset compliance? My data table, whatever I am preparing, the data table, whatever I'm preparing, it supports asset compliance. It is asset compliant in nature. Basically, what all transactions are happening in this data tables are as per the transaction rules of asset properties. Basically, it should obey the law of asset properties of a transaction. Uh, the transaction should be atomic in nature, it should be consistent, isolated, and it should be durable. We have already discussed above, so always remember like my delta live tables supports asset compliance, right? Which is not possible in data lake table, but yeah, delta tables always supports asset compliance. So I can write here delta live tables always support asset compliance properties. Number two, schema evolution. So what is this term called schema evolution? Let's say I'm having some tables which are used in the downstream. Okay. So I have one table in the source, right? I bring that table into target layer, let's say data lake. I have this table in SAP HANA, let's say. Okay. I brought this table into target, which is our data lake. I have done a lot of transformations in the table to get some kind of columns in the table, right? Tomorrow, let's say business comes back and say, hey Aditya, this table now has 50 records. Initially it has 35 columns. Now it has, let's say, 50 columns. So tomorrow business will come, hey Aditya, we are going to send you remaining 15 columns, which are the new columns, and every table from top to bottom has to be changed. So this will be a very big change in case my schema is fixed. But in terms of delta live tables, the lives of a data engineer becomes easy. Reason being, schema is evolving in nature. Basically, the schema is not rigid. It can increase or decrease based upon the needs of the infrastructure of the business. So schema on read is basically uh, whenever the data is being read, the schema evolves as per the data, whatever is being read, right? Initial days, the tables, whatever we used to build, were schema on write. We used to define the schema at first, and whenever data used to come, it should fit in those schema only. Schema on read is basically schema is created when the data is being read. So now, for example, data has 35 columns. The schema will have 35 columns. Tomorrow, if my data has 50 columns, the schema will evolve its shape so that it can include the remaining 15 columns also, right? So schema is always evolving depending upon the type of data or depending upon the size of data. Delta live tables support schema evolution. Schema on read is enabled whenever you are using delta live tables. Number third important point, time travel. Time travel is enabled on delta live tables. What does it mean? Basically, it's nothing but a feature of an audit table. I can go back in any point of time and I can fetch the records of that particular timestamp. Let's say 2015, someone who went to a supermarket purchased 500 candies of a particular company. So I can go back to the time of 2015 and fetch all the records of a particular timestamp to see whether those 500 candies were bought by a single person or not. So time travel is enabled on delta live tables only, which helps us for logging. Also, I mean, which helps us for storing the log files or audit the tables. So delta live tables support time travel. It's a very important feature which helps the user to go back to a particular point of time and pick up the data as per the requirement. This feature was not enabled in data lake which made the tables quite clumsy to be queried. That's why delta tables helps us to go back to any point of time, querying the data, helping to retrieve the right point or right set of data. Right. Number four, compaction. I can write as a performance. So performance of table when you're using delta life tables is very high uh, because of two reasons. Number one, the format of the data, the type of the data where you're storing, it is either Parquet or it can be ORC. In case of Hive, it is ORC, optimized row columnar file format. But in terms of Databricks, we'll be using Parquet format. So performance of our tables has increased robustly over the past few years because the compaction of the data is happening. Because whenever you're storing a data in a Parquet format, the size of data which is being stored actually is so compact in nature that it takes very less amount of space when being stored in the data or in the database. So this enhances the engine processing time. Basically, it goes to that particular point of time and fetches the data, right? Performance of engine has increased over the past few years because of data compaction and the way data is being stored, right? So these are the major advantages of delta life tables on top of data lake tables, right? You also have another feature called as Unity Catalog. I wanted to stress on this area. Unity Catalog is nothing but a catalog of data. This is, let's say, this is a book, kind of a book of data which has indexes or which has pages, page numbers of different chapters. Okay, so I can use the index to go to a particular page of the book to read that particular chapter, right? I need not read the entire book. I can just go to that particular chapter which I need to revise or read. So how I'm going to go? I'm going to read the index, see the content, which content is present in which page of the book, go to that particular page and read that particular page, right? So how this happens in the data is basically by the uh, by the new concept which is called as Unity Catalog. Unity Catalog is nothing but a catalog of data. Now, if I want to scan through the complete data, it is very difficult. So to quicken up this process, we have something called as index. Index will basically take me to that particular page of the book or to that particular point of the data which a user has asked to fetch. So I can go to that particular chapter, tell the user this is the chapter from which the data has to be retrieved, right? So the index will help us to query the data very fast and it will fetch the result in a much more fast pace when compared to how it was handled before. So Unity catalog is a catalog of data. By using indexes, our data search speed has increased, and that will also fasten up the querying speed of the data, also the processing speed of the data. Basically, the data which is being fetched will be fetched in a much more faster rate, right? So I have covered acid, CAP theorem, and advantages of delta table over data lake tables. Now let me go through the activities in ADF. So let me go to monitor tab. So I have already explained different uh, activities before, but yeah, I can go through a very small example with copying of multiple files. So If you see, so copy data activity is basically an activity in Azure Data Factory, which is used to copy the data from one source to a sink, right? Uh, if you see on the left side, I have created one activity called as copy multi-files activity, right? Uh, you can go to general tab, you can give some other name, it's okay. You can copy multiple data, let's say, copy multiple data, and you can hit on publish. So the data, the activity name got changed. Source is basically I'm giving a source data set. I created one source data set. This is I can just open it up. It is a CSV format. So data set is nothing but structure of the files, how it is being maintained. So in my source, I have CSV files. That's why I created a CSV file data set, right? I already have a link service which is used to connect my ADF to that data set. So my link service is already created, right? And I want to pick up some bunch of files which are in CSV format from one source and I want to place them in target. So this is my container. Okay, there is one folder called source and there are some file names. If I click on browse, you see ADLS container. I have some source and these are the different files which I have. So I want to pick up only those files which are ending with .txt or .csv. Let's say .csv. If I go back, so I'm picking all the files by using this data set, and part to file list is basically source list of files.txt. So list of file.txt is basically having multiple files or those files over which I wanted to create a list and I want to iterate over those lists to pull those files, right? So if you see the sink, so in this file, list of files, basically this file, I can't save it right now. Let me try if I can save it. Save as, download. Let's see if it has been saved. Uh, but yeah, I can show it in the portal only. Instead of using this, I can show it in the portal. I hope it will not ask me for authentication right now. I can go to home. I'm going to the container. Source. List of files.txt. Okay, download. Let me see if I'm going to download it. .text file. Save. Let me try to open it for you. Open with Notepad. So in a list of files, I want to copy or I want to pull these three files: employee lab.csv, json file.json, text file.txt. Okay. If I go back to my ADF, okay. So basically in my source, I have given the dataset name. Uh, you can give any dataset name. You have given the container name, the folder inside the container name, and the file name. Okay. File name you have not defined here because you are passing a list of files which you need to copy. So you just gave the path over there and path to the file list. This is the file which has a list of files which you need to copy. And if you go to sync, again you have a target data set. This is again a CSV data set which will help us to connect my ADF to the target, which is again in the format of a CSV. So my final files will be in the CSV format, right? So just think of like this. My ADF is used to pull the data from source to sink. My source is nothing but CSV file. I'm pulling the data from a source container in a folder. I'm pulling the data which is present in the CSV format. and I'm dumping the same data in the CSV format. So both my source and sync dataset will be in CSV format, right? Link service, you can use the same link service, and you are now pulling the data from source and you're placing them in target. So if I go back, you have a target folder, right? And you have something called as all these files which are coming. So if I run this pipeline, if I go back, you have not defined the file name, because automatically all those three files which is there, it will load. So what I'm trying to do is I'll go back to the main pipeline and I'll try to debug it. Let's see what happens. All my three files will be copied from source to sync, right? And the timestamp you'll see will be updated. So currently, without seeing, I mean the timestamp was on 8th Feb, JSON file.json employees.csv. Now we have to see the timestamp should change. It should reflect 13.2. So let me see if it is completed. Succeeded. You can refresh. You see 13th Feb, 13th Feb, and the other one employee lab.csv 13th Feb. All the three files got loaded from source to sync, right? So this is very much important topic. To copy multiple files, you can just pass dataset, right? You can pass a dataset. Basically, you can create a source dataset, and you can create a file list, right? Create a list of file, store it in the source container, pass that list of that file basically, which is nothing but a list of files with a source dataset. Open the source dataset, ensure the file list, the file which is being used is in the same directory what you are passing, and go back here, go to sync, open the dataset. Target is basically where you're finally loading your data. Make sure it is same. So basically you are iterating over that file which has different list of file names which are passing in the source path as a list of file. I have debugged it, and you can also practice the same thing. There is one more copy activity which I wanted to show, is to copy the data from SQL table to ADLS. So you can see this copy table activity. I can write it as copy SQL to ADLS, or I can just write short form copy SQL ADLS dash ADLS. Okay, I can use dash also, not a problem. So if I go to source, my source data set is nothing but a SQL server. Okay, if I click on open, you can see I have created a link service to connect to my SQL server. If I click on test connection, you see I am able to authenticate my SQL server, right? I am basically pulling down data from a SQL server, and I'm pushing it to one ADLS storage account, to a container. So my source is nothing but SQL server, right? I am basically pulling a complete table and pushing it to ADLS, right? If I click on open, this is a table, sales items. This entire table I'm moving it to SQL, from SQL to ADLS, right? So if you see here, my source is nothing but a SQL Server dataset in the format of a SQL Server. If I click on open, you see this table basically in a database. I have this table. DBO is the schema or the database name. I have this table, sales item. Entire table I'm copying from SQL Server to ADLS. So if I go back, right, and sync is nothing but my target where I'm putting it. So target again is a storage account, and that storage account target I'm using a CSV format dataset, or can use any dataset where I'm loading my final file. You can click on open. Since I'm connecting to a CSV file, I mean my final table, whatever I'm putting, it should be in the CSV format. So I'm using CSV dataset. Link service, we already have it, so we have used that. Container target sales items table. So if I go here, container target sales item table is nothing but the table which is derived from SQL Server. If I go back and if I run this pipeline, debug, Here you can see it was copied on 12th of Feb, right? I'm running it again. We'll see it is running. The date timestamp should change. Let it run for some time. And once it is computed, we'll see the timestamp to be updated. I can refresh it once. So it will start my SQL Server engine and it will copy the data from SQL Server. From that particular database, it will pick up that table, load it in CSV format and dump it in my ADLS, right? I can just refresh it. You see now timestamp will change from 12 to 13. Refresh, timestamp has been changed, right? Let me go back. So I have covered these two activities, right? Copy data is nothing but one of the most important activity in ADF. It is used to copy data from source to sink. Source can be ADLS to ADLS, SQL Server to ADLS, any format, right? Now let's go to for each activity. For each activity is kind of an iteration, right? Like for loop in a code, we have a for loop in ADF to iterate over something, right? So if you see this activity, we have two different activities. One is for each activity, and we have one lookup activity. Lookup is basically to find something. So they have given this activity name as lookup. I am looking up a source system, right? Basically, I am looking up into a SQL Server source. If I open the data set, I am looking for this table, sales items table. Okay. If I open this data set, I am looping basically one second. So for each activity means I'm for this first one is lookup activity. I'm looking up for a SQL Server database DBO. Inside that, I'm looking for a table called sales items. Okay, I'm looking for that table name, right? And I'm not passing the entire table. I'm using a query. So what query we are passing? Select star from information schema dot tables where table type is base table. So select star from information schema dot table. So basically select all the tables in this schema. Your type of table is base table. Let me cancel it. So from list of tables, I am taking only that table where the type of table is base table. So I'm looking out for a base table, right? Let me go back here. I'm looking out. I'm passing a SQL query. It goes to that uh, schema name dot sales items. There it will run this query and it will go to for each activity then. Basically, it will pick up all those tables whose table type is base table. Let's say there are five tables. Now it will iterate over all these five tables. So for each activity, if I go inside settings, items, basically based upon the output value of this lookup activity. See, if you see here, the lookup activity output value it is taking, right? It is going to iterate over those items. And what is the activity we are doing inside for each? We are copying one by one. Let's say lookup activity output is 2. So based upon each output, it will perform a copy activity of each and every activity. So if I click inside, edit, if I see copy, source is we have one data set, basically a source data set in the format of SQL Server, right? Table schema is nothing but the table name, which data type is as base table, right? And basically, if I preview the data, I am going to fetch all those data sets which are having table schema or the table type as base, right? So I'm iterating over those tables, right? If I close this, I'm closing this. So this is source. I am using a table schema. Table name is item at the table name. Data set name I have defined. And my sink will be a sink data set container target for each output. And you see if I go inside for each output, I have all these tables whose base type is whose type of table is basically nothing but base type, right? If I'm directly running this one, I can see the timestamps being updated. Close this for each, go to for each loop. Let me debug it. We'll see what happens. So basically, lookup activity will first go and look up into SQL Server based upon that query which you are passing. In that table, dbo.items table, it will go and run this query. Select star from information schema dot tables, where table type equal to base table, right? It will run this query and first filter all those tables which whose type is base. Now it will iterate over those tables and copy it, right? That is the concept. So we'll see from 7th of Feb, the timestamp will change. I'm just updating this one. Once this is completed, we'll look up this is completed. Green signal came. Copy activity 1 passed. So we'll see which activity completed. Okay, these two tables got pasted. Other one is running. All the data copy completed. I'll refresh it. And you see all the data timestamp has been completed. So we have sales items.txt, which is nothing but this data set, sales items. So this table, dbo.sales items, along with in the for each activity, I'm also passing this query. What all tables of table data type as base type will be copied as a for each activity by using a copy activity inside the for each, right? So today's class I just wanted to cover these three basic activities. Maybe in the next class I will take you through the next different activities and then we'll finally build a project on top of it. Hopefully you have liked the questions, the sessions. If you have any questions, do let me know. We can again connect and we can discuss over that. But please practice this exercises. I have already done it to for saving some time. But yeah, we'll go through some more easier examples and then we will create one pipeline. This will be the last module of all the 6 modules, whatever we have covered till date. In this module, I'll be focusing mainly on one of the practical examples of incremental load. Before I talk about and deep dive into incremental load, let me talk about the different types of load we have in data engineering. So the first load will be called as full load, or it can be called as flush and fill kind of load. The second one is incremental load, or it can also be called as a delta load. The third one is called as a custom load. So I'll be giving you some kind of examples which will be helping you to define the definitions if it is asked in the interview, and practically you're going to cover the incremental load. The pipeline is already designed, but I'll be giving you a walkthrough of how you can create an incremental load in practical scenarios. So first, let's talk about what is full load or what is a flush and fill load. So full load, these are basically used for small tables, basically uh, tables whose volumes, or you can say size, is small, right? So to load any full table, uh, basically to do full load or flush and fill, uh, the size of the table should be small, right? First criteria is the size of the table is small. So people will ask me, okay, well, how much should be the size of the table? So any table whose record count is less than 50,000 or 50K can be considered as a small table, right? Now, depending upon the use case scenario, if the tables are, static tables or dynamic tables, the values of tables are changing day by day, you can do a full load. You need not do incremental load on these tables. You can directly delete all the data every day and load the data in that table again on daily basis. You can do this, and it will take less time because obviously the number of record counts are less than 50K or up to 50K, right? So this kind of load is called as a full load. You are loading the entire table every day and all the records are loaded. So let me take Paint. I'll explain. Uh, Let me take a box. So let's say this is a table. Okay, it has 50K records. Let's say 40K records. And next day again, I need to reload this table. Maybe some records got inserted or some got updated. Let's say from 40K, now the records are, I can say like 40,200. Okay, 200 records got added. So since the size of table is small, I can do a flush and fill. Flush and fill is basically, suppose I have a data in this table, I'm going to delete all the data and I'm going to reload the data, reload the table with the new table, with the new data. Basically, from this to this, we're going to get a new table. We are going to move all the data 40K as is. Also, we're going to load what additional records were added. So I'm going to delete the entire table and reload the table with the new records or the supplementary records, right? So daily, so today I have 40,200. Tomorrow again, let's say the record got increased. So you can say like 40,300 now, 40,400, for example. So again, on this table, I'm going to do a flush and fill. I'll remove or truncate or delete, basically truncate all the data, whatever is present, and then reload the table with the additional data or newly inserted data or updated data. So daily I'm doing this process, right? I'm removing the data and I'm loading the entire data again. So you'll say, okay, if I'm removing the data, from where I'm getting this data? So before removing the data, I will stage this data. I will stage 40K records somewhere. I will save it or I'll archive it somewhere. I'll also see how many new additional records were added. So that will be also present in the stage in some folder. So together I'll be combining both the data and I'll store in the same table. So I'm deleting this entire table, reloading the data with the fresh records or the newly inserted records, right? This process is called as flush and fill or full load. I'm loading the data in the same table again and again fully. That's how it's called as a full load, right? Loading the entire data in the table is called as full load or flush and fill. You're flushing the data and you're filling the data with the newly inserted records or updated records, right? Now, what is called as incremental load or also called as a delta load? So, this kind of insert, I would say insert plus up. The upsert is called as update plus insert. This kind of upsert is basically used for larger tables. Larger tables, anything which is having more than 50K records, right? Uh, so how you do a incremental load? So to perform incremental load, first time we do full load, and the next day onwards, we only push the incremental data. Okay. So let's say I am moving from 2023 to 2024. I bought entire data till 2023 as a full load. And now for Jan, Feb, March, I'll be bringing the data in increments. For example, I'll be bringing the Jan data as one period. Then I will increment on top of it to get February data and then March data, right? So this kind of load is called as incremental load. I'm getting the entire 2023 data, which is a huge data, in one shot, in one go. And then I'm loading the data incrementally for the next periods, right? That's the best example I can give you for incremental load. Incremental load also can be performed on daily basis. I bring, let's say, 1 week of data, and from the next day onwards, I want to increment the data. So last 7 days data I brought as a full load, and from the next day onwards, I'm incrementing the data. That is also called as an incremental load, right? We'll explain incremental load as a kind of a mini project, which will be helpful for the people to perform on ADF. Before that, before showing the pictorial representation of incremental load, I also want to cover custom loads, right? What is custom load? It means loading data in custom manner. Uh, for example, loading last 1 month of data, or last 1 month can be called as last 30 days of data, basically, right? Or you can say loading last 7 days of data, or loading day minus 2 data, day minus 2 days of data. So what I'm trying to say is, here we're not following a particular rule. We are coming with a in custom load. Basically, today is, for example,